Welcome to this 4 hours long Delta Lake full course in which you will learn processing real-time data using Spark structured streaming, building ETL pipelines using Delta Live tables, append flow and slowly changing dimensions in Delta Live tables, schema enforcement versus schema evolution, performance tuning with ZORDER by and optimize command, liquid clustering, ACID transactions in Delta Lake, deep cloning and shallow cloning, deletion vectors in Delta Lake, schema updates in Delta Lake, and we gonna use Unity catalog in this whole video. But wait, why you should watch this video? Because Databricks is very much in demand, and do you know what? Delta Lake is the backbone of Databricks, and there have been so many updates in the world of Delta Lake, and it's time to cover all of them. When I was learning Delta Lake, I had to refer so many books, so many playlists, attended so many webinars, and finally I've created one-stop solution for you to become a pro Delta Lake developer. And do you know the best thing is you will be learning everything from scratch. Now what? Just take out your notebook and just start taking notes. But wait, just hit that subscribe button. I know you have already done that. So let's go.
What's up, my data fam? What's up? First of all, happy Sunday. And I know you were waiting for my video. So here I am back with another video, and happy new year to all of my lovely data family members. Happy new year. And I really wish that you get placed in your dream companies and you excel in the world of data engineering. I really hope for the best for all of you. Okay, so do you know today's lecture, today's session, today's video is very special. Why? As you can see on the screen, it's about Delta Lake full course. If I talk about data engineering domain, it is one of the oldest domains in the world of data, right? Data engineering. And do you know what is the most youngest member in this whole domain? It is Delta Lake. And do you know what is the most favorite member of this data domain right now, data engineering domain? It is Delta Lake. It is Delta Lake. And you know my next question. What is the most in demand technology right now? What is the most in-demand framework, technology, file format, anything you can say? What is that? It is again Delta Lake. So if you want to grow in the world of data engineering, you have to master Delta Lake. So now there are two things, like there are like two kinds of people. One, who know Delta Lake to some extent. They know like how to create delta tables and how to just update it. That's it. Second, the second category is the one which really make the world competitive. They know all the insides and outsides of Delta Lake. They actually know what exactly they are doing with Delta Lake, what exactly things are happening behind the scenes when they just take any action in the world of Delta Lake. They know all the things, and that's why they can just optimize their code, they can just optimize the performance, they can just do lots of stuff, lots of stuff using Delta Lake. This is the sole reason. So I was just thinking like, what should I just share with my data fam next? Then I got the message, and I got it's Delta Lake. So I thought like I have to put my data fam in the second category, who know everything about Delta Lake. And when I say everything, I mean it. Because in this particular Delta Lake full course, you will learn all the things. Everything. The smallest thing, the biggest thing, the trickiest thing, the most complex thing, everything. And you know that when you just click on the video on this channel, you do not actually need to worry about the complex things, right? Because I'm here. Ansh Lamba is here to just explain you everything. right? So everything is sorted, man. Everything is sorted for you. So now, let me show you what is the agenda of today's video. Okay, when I say that we're gonna learn a lot of things, let's have a look at the list. And this is just the overview of what we are actually learning today. And we're gonna go so deep today. So, first of all, data architecture's transition. So, before actually working with Delta Lake, I will just give you an overview how things actually were working before Delta Lake and how transitions happened with the time. So, now it will just build a strong base for you and you will know why you need to use Delta Lake. Most important question, right? You will learn this. Then, what is Delta Lake and Delta Log? Okay, so what actually it is Delta Lake? What actually is Delta Lake? We need to understand that. Is it a file format? It is a table format? Is it like what? Is it an architecture? What is that? We will learn it. Okay, then we will just kickstart our Delta Lake journey. Okay, and we're gonna use Databricks, obviously. Okay, and one more tip. So in this particular video, we're gonna use Databricks with Unity Catalog, which is like cherry on the cake. Trust me, like Delta Lake, obviously, it's like a cake. Databricks with Unity Catalog is like cherry on the top of the cake. Because Databricks, we all know that is very much in demand, but now it is only in demand if you know how to work with Databricks using Unity Catalog. Otherwise, no, bro, you are not in demand. But now you're watching my video. Now you also will be in demand, and now you also will be cracking the offers because I will teach you each and everything. Okay. Then we will just talk about DML in Delta Lake. DML like data manipulation language in Delta Lake. How we can just update our tables, delete our tables, like all those operations, right? That we perform in normal standard SQL tables. So we will learn how we can just do all those performance in Delta Lake. Then time travel in Delta Lake. What is time travel? Obviously, yeah, I'm going to talk about time travel and all these things in detail, but this is just like as the word suggests, we can just time travel. We can just go to the previous versions of the table as well. That is the most powerful thing, one of the most powerful things available in Delta Lake. Okay. And then optimize ZORDER by liquid clustering. Obviously, if you are working in any company or if any company wants to hire you, why they would hire you? Only if you can optimize their performance, only if you can optimize their code. That's the outlier thing, right? You will learn that too. Deletion vectors, that's the recent addition in the world of Delta Lake. You will learn this as well. So if in your interviews you get questions related to deletion vectors, you should feel happy. Why? Because you will learn all the things related to deletion vectors as well. And if you do not get any questions regarding deletion vectors, you can just add this thing whenever you are just giving answers. So interviewer would know that this guy or this girl is like a pro developer. Okay, then schema handling. This is the most important thing in the world of Delta Lake, because in the world of big data, we cannot say that, okay, this is our source, this is our schema, and we want to use the same schema throughout the pipeline. No, it can evolve, it can change, right? So we need to know how we can handle all those things, all those things. And what about the data engineering interview questions? I get lots of comments like, can you please create a video on data engineering interview questions, data engineering interview questions? So just hold on. Do you know like what is the most favorite topic for like data engineering interviews right now? It's about open table formats, it's about Delta Lake, it's about optimization, it's about schema handling. So this video, I can say, will cover at least 50% of your interview questions. And this is not just inclined towards any one cloud platform. This is for all the cloud platforms, because Delta Lake is like easily linked to all the cloud platforms. So it's not like you will just cover the data engineering interview questions with Databricks. No, this is Delta Lake. This is a kind of architecture. This is a kind of format that we are using right now. And This covers the fundamentals, implementation, everything. So this video is for you if you are looking for interview questions. Trust me. Do not rely on those questions like what is this? What will be the output of this? These are not the questions, bro, that you need to prepare. If you know these concepts in detail that we're gonna talk today, you can easily answer those silly questions like what is the output of this, what is the this. These are the real questions. These are the real scenario based questions. Data engineering is not just about code. It's not just about like how to just display this output. No, that is just like that can be just like one of the interview rounds, like one of the technical rounds. If you are just aiming for a big company, after your technical round one, which will be covering those silly questions, then your technical skills will be tested based on these scenarios, because they're gonna see how competitive you are, how updated you are in terms of knowledge, and how easily you can just tackle with these scenarios, right? Very good. Then streaming with delta table. Streaming with delta table. Yes. So we're gonna see how you can just perform streaming with delta tables, and the most popular thing right now, and it is a very hot topic. So it is none other than delta live tables. I know this is very popular, and everyone wants to know like what are delta live tables. So basically you will also learn about delta live tables as well in today's video. So before starting the video, there's a long list of prerequisites, so let me just show you what's that. Okay, so I was just kidding. So there's no long list of prerequisites. First of all, the most important thing according to me, if you want to just complete this video, and not even just complete the video, even if you just want to start the video, excitement to learn delta lake. If you are excited, then only just continue watching this video. If you are not excited, you know my answer. So if you're excited, and I know if you are my data fan, you are excited. Second thing, laptop or PC with stable internet connection. Obviously you need to code. You cannot code in phone. I used to code in phone back in days, yeah, but that was only Python. You cannot build, or you can say create Databricks notebooks using phone. Okay, so you should have a laptop or PC, so you can just code on that laptop or PC, whatever you want to use. Okay, then the third thing, if you want to crack your dream company only and only, then you should just watch this video. Otherwise, just cover those fundamentals and like the basic things, not just fundamentals, like just the basic things, and just go on, just carry on. If you want to crack your dream companies, then only you should watch this video, because this video will take you on a journey which will cover all the fundamentals, all the implementations, everything in the world of delta lake. And I have already told you that this is the most in demand technology right now. This is the most in demand technology right now in the world of data engineering. So if you want to crack a dream company, then only watch this video. Otherwise, you know my answer. Okay, so if you fulfill all these 3 points, you're good to start, bro. You're good to start. Okay, then let's talk about data architecture transitions first. Okay, so as I just told you, so I will just give you a quick overview like how things were before and how things are right now. Okay, so let me just show you. So I will just take you to a documentation page, and there we have a lovely visual, and I think that is the best visual that I can use to explain you the stuff in a quick way, in a short way, and in the best way, so that you can just grab the information. Because when you understand the concepts using visual, you can retain that memory in your brain for a longer period of time. Ansh Lamba, Mr. Ansh Lamba, have you done any bachelor's or master's in neuroscience? The answer is no. So why and how do you know all these stuff? Because in my free time, I watch like these videos. So I thought like I should just pass on this knowledge as well. Okay, because my duty is to just share the knowledge. That's it. Ansh Lamba is here to just share the knowledge. which can help you to grow. That's it. And if you want to grow, it's not just about learning how to code, learning how to build pipelines. It's about the lifestyle. It's about the vibe around you. It's about the aura that you have around you, right? Okay, so let's quickly see how we can how we just transition from like one architecture to second to third, and how things are actually performing right now. Let's see. So this is the documentation page, and you can just go to Databricks and just type data lake house, or just type on the Google like data lake house Databricks. So you will just land on this page, and this is the visual that I was talking about, because either you can just read big text written on the pages, or you can just watch this part of this video and you will just grab everything. So basically, initially we were just working with data warehouse. Okay, just forget about this part, like Delta Lake and Lakehouse. This was not existing at that time. Okay, so only data warehouse. And we know like the traditional data warehouse that we have, like we were storing data in the traditional databases like MS SQL Server. Let me just write it for you. It will be a good understanding for you. And wait. Where's the notebook, bro? Where's the notebook? If you have not taken out your notebook, if you have not taken out your notebook, just take out your notebooks right now, because we have started our lecture, we have started our session, and without taking notes, you are not superhuman who can just remember everything. So it is very important to just take notes. When you take notes, you feed your brain, you put efforts to actually understand the thing, because when you actually write, you think about that, right? So just take notes. Again, neuroscience things. Ansh, Lamba. MS SQL Server. Okay, just take notes. So basically, we were just storing data in like MS SQL servers, or like MySQL, PostgreSQL. Like so there were like so many databases, right? So we were actually storing all that information. We were just building dimensions, facts, everything, and in those on-prem databases, right? Then with time, with time, with time, this came in the picture. Delta Lake. Everything was running fine. Everything was running fine. Wait, Ansh Lamba. If everything is running fine, like why we need to jump to Data Lake? Very good question. So, with the rise of big data, with the rise of big data, some problems started to come, such as like earlier it was like four V's, but now we have like so many V's. The main four V's are like the main four V's: velocity. Let me just write it for you. Velocity, volume, variety, veracity, I guess. Yeah. Basically, there were like three main V's, then it was like four, then six. So because of these four V's, first of all, velocity. Data was coming with such a speed, it was really hard to process the data as well and maintain the lineage as well. Then volume. Data was coming in such big sizes, so it was not performant enough to actually hold that data. And if it was like holding that data, it was very expensive, because obviously they need to just increase the compute, they just need to increase the storage sizes, like everything. It was very expensive. Then variety. Data was coming in different formats, like semi-structured format, unstructured format. It's not just about like data is coming in the structured format only. No. So veracity. So you can just check the spelling. I don't know. So veracity. So data was not secured. What do I mean? So basically, with these disruptions, we could not trust the data, because data is coming with such a speed, with like in big sizes and with so many varieties. Business was not able to trust the data with so many variations. Then they decided to include a structure called data lake. Okay, data lake changed the whole domain, because it was able to handle semi-structured, structured, and unstructured data. That was the revolutionary thing. You can just store your videos, images, semi-structured file formats such as JSON, a structured file formats, obviously like database, everything. And it was so cheap. It was so cheap. The main outlier thing was the price. It was so cheap as compared to the traditional databases. Okay. And everything was running fine. So people were building data warehouses, people were using this data, like data scientists were using this data for like machine learning stuff, for reporting. Then with the course of time, they realized that their BI reports were not performant enough. There's no problem with data science, no. There's no problem with machine learning, no. There was problem with BI reports and reporting domain, like the BI reports, the dashboards, everything. It was not performant enough with data lake, with the data stored in the data lake. So what they were doing, they were putting their data in this data lake. Okay, then it was used by data scientists, it was used by like other machine learning developers. Then they were building ETL. They were building ETL pipelines. Let me just zoom it for you. They were building ETL pipelines on top of the data lake, and then they were building data warehouses on top of the data sitting in data lake. Why? Because reports are only performant with data warehouses. So this architecture continued for a long period of time. Then they decided why we are just doing these steps, and why we are just storing data, and why we are just making duplicate copies of data. First we are storing data in data lake, then we are just applying ETL on the same data and just populating that data in the form of data warehouses again and again. Why we do not have a kind of architecture in which we can store the data, which can hold structured data, semi-structured, unstructured, and it will be used by data scientists, obviously, and that data does not need to be pulled through ETL pipelines to build data warehouses again, because that particular architecture will actually fulfill the demand for like BI reports and all. Then we got the architecture called data lake house. So what it did, so basically, as the name suggests, lake house, it is the combination of data warehouse plus data lake. It combines and creates the architecture called lake house. So data will be stored in the form of data lake, like in the data lake, which can hold structured, semi-structured and unstructured data. Okay, then obviously we know like this data can be easily used by data science, but for BI reports, they created the metadata layer. Here comes the role of delta lake. Yes, here comes the role of delta lake. Ignore my handwriting, I know it's really beautiful. So here comes the role of delta lake. So Lakehouse is incomplete without delta lake. Why? Because when we say we want to build warehouse, we need all the functionalities of data warehouse. What are those functionalities? Such as asset transactions. What are asset transactions? Atomicity, consistency, isolation, durability. These are like four have to have transactional functionalities of a data warehouse. So delta lake guarantees this. Okay, time versioning, like we can just put commit and rollback statements, everything. So all these things are supported by delta lake. Okay, and this is the architecture that we are following. And just tell me now one thing, I have one simple question. We as data engineers are using this architecture, Lakehouse, and delta lake, or you can say open table file format. I will just talk about it, don't worry. Open table file format is the backbone of this whole architecture. Now people are just running after like, what should be the interview questions, just cover the interview questions, just cover this technology, just cover that technology, just cover that technology. Bro, just cover this backbone in detail first. After this, you can become a pro developer in any technology. Either it's Azure, AWS, GCP, anything. This is the backbone. This is the structure that you need to understand. When I say fundamentals are important, I mean fundamentals like data warehousing, ETL, initial load, incremental load. I know these fundamentals are important. These are like fundamental of fundamentals. But now this particular chapter, this particular backbone is also the part of fundamental. And I don't know why no one is talking about this. Like, this is also the part of fundamental. And you should know this. And in today's video, we gonna cover fundamentals and implementation as well. So we gonna use Databricks, as you all know, and we gonna use Databricks with Azure. But all the AWS lovers and GCP lovers and any other cloud platform lovers, it's not about covering this technology with Azure. It is independent of any cloud technology. We gonna cover Delta Lake basically. So if you love AWS, if you love GCP, you can just create the same steps in your favorite cloud providers, or you can just follow these steps that I'm just showing you right now with Azure, because it's not about you will be exploring Azure. No, we just gonna use Azure to create Databricks workspace. That's it. That's it. That's it. And after that, it will be pure Delta Lake. So choice is yours. Okay. And I hope now you know everything, like what architectures, like how transitions actually happened. Transitions actually happened. And this Lakehouse, data Lakehouse is like very new as compared to like data warehouse. Data warehouse came in, I think, 80s, and data lake came in, I think, 2010, and this Lakehouse came in, I guess, in 2000. Let me just check in the book. So basically, this book is a gem. It's called Delta Lake Up and Running, and it is written by Benny Helen and Dan Davis. So I actually spent a lot of time to read this book, and what a lovely book. What a lovely book. And obviously, I will just sharing all this knowledge with you today. Everything, everything, everything. And this book has like everything. And this is like this much of pages in this book. Do not need to worry, you will learn everything. And definitely, like, I will recommend you if you want to read this book, but I can assure you that this video will cover everything. So yeah, so this lake house actually came in, yeah, 2020s. So data warehouses were in the picture in 80s 90s. Then data lakes came in like 2010s, early 2010s, and this lake house came in 2020. Just imagine, it's not even 5 years old. It's not even 5 years old. And just tell me one thing, people say that experience is really required to excel in the world of data engineering. I respect that. I actually respect that statement. But just tell me one thing. Just tell me one thing. This whole architecture, this whole industry changed in the last 4 to 5 years. People with 20 years of experience, 15 years of experience, 25 years of experience are standing at the same stage where you are standing right now. Where you are standing right now. Only and only if you know the fundamentals. I'm just imagining that you know the fundamentals. Okay, fundamentals mean like everything. I'm not saying that experience do not matter. Experience do matter, but for me, skills is at the top level of the priority. Is at the top level, because this whole industry just changed in the 4 to 5 years. Whole industry. Person with 20 years of experience, okay, person with 5 years of experience, if they know the fundamentals, and obviously fundamentals are same for both these scenarios, obviously this person has like some advantage of dealing with scenarios, dealing with errors, dealing with like so many debugging situations, everything. I respect that. But if this person has like 5 years experience, this person also had encountered with like enough scenarios, and now if this person with 5 years experience is exponentially, is consistently upskilling, and this person is just relying that I have 20 years of experience, I have this years of experience, bro, for me this person is more skillful than this person, trust me. Because now is the era, if you are consistently upskilling yourself in the world of data engineering, then only you can excel. Do not flex in the world, in the front of world, that you have 10 years of experience, that you have 20 years of experience, that you have 15 years of experience. Hold on, and just hold on. For you, my data fam, upskill yourself, cover your ears, and just see how this industry will change. People will respect skills more than the experience. Trust me, mark my words. It's just the matter of like 2 to 3 years. You will see the change. People in the world of software engineering, they do not say these things like you should have like 10 years of experience, you should have like 20 years of experience. Big companies hire the talent. People completing their bachelors, they are just like 21, 22 years old. They have like hardly 1 year of experience. Still they build the most adapted technology, like they build the search engines, they collaborate in the most advanced projects like in Google, Microsoft, Amazon, Netflix, Apple, like all these man companies and other like big companies like Nvidia and all. They do not say, hey, you are just passed out, you have just completed your bachelor's, you do not have 10 years experience, just stay away. No, they have spent at least 2 to 3 to 4 years. They have like upskilled themselves consistently, and they know how to build those things, they know how to contribute. Okay, so just cover your ears. If anyone says that you need 10 years of experience, 20 years of experience, no, you just need skills, just upskill yourself, that's it. Whole industry will change. Just see, just mark my words, just upskill yourself. Okay, so this was all about a philosophy talk, and this was required. See, you need to have that vibe if you want to reach anywhere. You should feel that vibe. Okay, I do not want you to feel demotivated. Hey, you are just a new, you can say a new entry in the world of data engineering. Should you get the job, bro? What is this word, should you get the job? If you need the job, just crack it. Who am I to tell you that should you get the job? You are the one who is applying, who is working hard, who is consistently learning. You need to say that I need to crack this. What is this word like, should you get the job? Bro, okay, let's get let's get back to the topic. And so we have seen like how data architectures and how the transitions actually took place in the world of data engineering. So now is our next topic, and this is like what actually is delta lake. Let's see what is delta lake, what is delta lake, and what is delta log. Let's see. So let's talk about what is delta lake and delta log. Concept is really simple, and if it was not simple, now it will be simple because now I am explaining it. Okay, so the thing is, basically people say that it is a file format like delta format, some people say like it is a table format. So basically, by definition, if someone like asks you like what is delta lake, just say it is an open table format. Okay, this is just an open table format. What it does, what if I say that delta format is not a file format? Okay, so why do people say that just save your data in delta format, just save your tables and delta format? Like, why? Okay, have you heard about Parquet file format? Very good if you have heard, because it is a very popular file format. So the thing is, actually delta lake is built on top of Parquet file format. Okay, so let's say this is your Parquet file. Okay, let's say this is your Parquet file, and it's called like Parquet file Ansh, let's say dot Parquet. Okay, it is just a Parquet file format, and it is sitting here in your storage like cloud storage or anywhere. Okay, so this is called Parquet file format. What if I say this will also be called as delta file format? Why? How can one file be called as Parquet and the same file can be called as Delta file? Okay, here comes the role of Delta log. When I create Delta log, let's say this is your Delta log, and let me just write with my beautiful handwriting. Oh, this is really beautiful. Okay, so Delta log. When I create Delta log on top of this Parquet file format, it becomes Delta format. Simple. This is a very generic overview, so do not worry. I'm just covering all the things. So when we have like, let's suppose you have like orders information in your Parquet file. Okay. Now, when you create this Delta log on top of this Parquet file format, it becomes Delta format. Now, can I say this is Delta format? Yes. Now I can say, because now I am considering this whole file, this whole thing as my file, as my file format. Mr. Ansh Lamba. Okay. Let's say next day, by the way, who is calling me Bhaiya? I was just reading comments and I was like, Bhaiya, this. I respect the word Bhaiya. It's fine. It's fine. It's fine. But do I look like Bhaiya? I'm I'm just a kid, bro. I'm just like 24 years old. Like, why are you calling me Bhaiya? Just call me bro. It just came to my mind right now. So do not call me Bhaiya, okay? Just call me bro. I'm of your age. If you are in college, okay? I'm very young. I'm very young. I'm just 24 years old, okay? If I look like 30 years old, 35 years old, I don't know. But I'm really, really young. I can just show you my identity as well if you need. So I'm a part of Gen Z, bro. I born in 2000. So do not call me Bhaiya. So Ansh, or just call me Ansh. I'm fine. Do not call me Bhaiya. So the thing is, let's say next day, one more file came in the same folder, okay? And it is with Parquet file Ansh2 dot Parquet. Will there be another Delta log for this particular file? The answer is no. The answer is no. That is the specialty of this Delta log. So what it does, it is basically now we need to cover Delta log as well. Like what is Delta log? Okay, this is a transactional log or transaction log. Transaction log, yeah, perfect. So this is basically a transaction log. Okay, what it does, it keeps all the transactions, it keeps all the information, it keeps all the metadata, everything. Don't worry, I will just show you as well, like how it looks like from the inside, everything. It is just an overview, bro. I know you are really excited. Just hold on, just hold. I'm double excited. Don't worry. So this is the transaction log. So when we create this transaction log on top of our files, it keeps the history, it keeps the information, it keeps the metadata, it keeps the everything in this Delta log. So let's say if I add my second file, so what will happen inside this Delta log? So it will just keep this information, it will just take this file name, this one, okay, and it will store this information. This is, hold on, Ansh, stay calm. Okay. So this will store this information inside this transaction log, inside this transaction log, and it will say, hey, my file format or my table, this is also the part of Delta file format. Simple. Let's say I remove this file. Then what will happen? It will say, hey, transaction log, just remove this file format from our log because this is no more. No more. This is removed. Okay. By the way, this is a concept. I was just attending one seminar by Databricks, and it's a very like catchy concept. It's called tombstoning. It's called tombstoning. Let me just write it for you. So it's called tombstoning. That means if this file is not in the folder anymore, so it will be tombstoned from here. Okay, why we call it as like tombstoned? You will know everything. Don't worry. Just remember this word like tombstoning. Okay? Because this can be asked in your interviews as well. Like, what is tombstoning? And this is like very catchy word. You should know. Okay? So now, all this information, all this transaction logs make our Delta Lake, which can support asset transactions like asset transaction A, C, I, and D. Atomicity, okay, and then consistency, and then durability, isolation. I hope you know like all these things because these are like fundamentals. And very popular is like atomicity. So let's say like how it covers asset transactions. So basically, let's say this is our data, okay, and this is our first packet file, okay, and this is our delta log, okay, this is our delta log, okay. So this information will be written here, okay, and it will say just add this file, okay. Now next day this file came here, but in between it was corrupted, and that writing behavior was stopped in between, but some part of that data is written here, some part of the data, because it's a like data movement, right? But it was not completed, it was not succeeded. So our delta log will not keep this information. It's called atomicity. It will not count this partition as the part of this delta log. And just a hint, I know and that I'm gonna cover all these things in detail. Just a hint, only those files will be read which are stored here, which are referred here. So this is our first file, this will be referred, second file will not be referred because this is corrupted data. So these are like asset transaction support in Delta Lake. Got it? All good? So I think now enough fundamentals and enough base is built for you. Now we're gonna cover fundamentals along the way because we need to show you practically as well, and that's the best way to learn, that's the best way to grab the information, right? So now let's create our Azure free account, and I will just show you how you can just create one, and then we will create the Databricks workspace inside that free account, and then we will just kickstart our learning. Okay, let's see. So you simply need to go on Google and just type Azure free account, and if you are already a part of my data fam, you already know like how to create a one Azure free account. If you are new, I think by now you should have clicked on the subscribe button because you know like how easily you're gonna learn everything. So I hope that you have just clicked on that subscribe button. Okay, so in this Azure free account, just first of all click hit enter. So just click on the very first link, okay, and then you will see two tabs. Just click on this Azure, try Azure for free. Just click on this, do not click on this pay as you go, just click on try Azure for free, okay. Then you just need to put your Microsoft account. If you do not have one, you can just click on this create one account and you can just put the credentials, and obviously you can just use that Microsoft account later on. Then when you just click on this next button, it will just ask you to fill the form, the like big form, like it will just come like this, and you just need to put the information like everything. Then you just need to click on sign up button, and after clicking on sign up button, let me just tell you, it will just ask you for the card details and all. So do not need to worry, it will not charge you because you will get $200 credit for like first 30 days, and you can just spend those credits in like first 30 days. And after that, if you do not want to continue the services with Azure, you do not need to do anything. You do not need to cancel any membership at all. It will be auto cancelled and all your resources will be nullified. So you do not need to worry. You will have the opportunity to upgrade your account to pay as you go if you want to learn further in Azure. It's up to you. I have personally upgraded my account so that I can just learn Azure more and more. It's up to you. If you want, you can, but it will not charge you until and unless you upgrade your account. So Azure will not charge you. Why it is asking for card details? So that it can just verify that it is you who will be just using and learning Azure. because obviously Azure is just giving you $200 credits so that you can just learn Azure. So they just need to verify that it's you. Okay, so after doing this, let's create our Databricks workspace. And how we can just create, we first need to go to Azure portal. As I just said that we do not need to explore Azure much, because we will be just directly jumping to the Databricks workspace. That's it. Let's do it. So you just need to go on Google and just type portal.azure.com. This thing, let me just zoom it for you. Portal.azure.com and just hit enter. Let me just type it for one more time. So this is your Azure portal account, and if this is your first Azure portal account, then welcome to my lovely Azure, because I love Azure. Azure is my first love. First or second? Second? Third. Okay. No personal talks, Ansh Lamba. Okay. So I love Azure, and I just love the UI. I don't know, because I think blue is my favorite color. Just kidding. Just kidding. I really like the icons, and I really like that UI. I really like the vibe of Azure. So we do not need to just explore Azure much. So we will directly jump on to our Databricks workspace creation. By the way, we just need to create one resource group. If you are new to Azure, then let me just tell you, we create resource group so that we can just store our resources within that. And resource group is nothing but just a folder in which we just keep our resources. And resources are just like Databricks, Data Lake, everything. And as I just mentioned that we will be using Unity catalog so that you can just learn everything under a single video. And for that, we create our own external data lake. So we will be creating two resources in total. One is Databricks, second is Data Lake. Okay. So let me just show you how you can just do all the things. By the way, just ignore these stuff. These are like my personal stuff. So just kidding. So these are like resources that I have used recently. So yeah. So let me just click on this search button, and first of all, I will just type resource group. Okay. And you can just click on the pop-up, and I can just click on this create button. Okay. Okay. So I will just name my resource group, and I will say RG Delta Lake, because we are learning Delta Lake, so it makes sense. Okay, simple, bro. And which location you want to pick? Which location? Let's pick US West US 2. Let's pick South Central US. Just kidding. You can just pick any location. Why I'm worrying, I will just show you, because I've already created some meta stores in my some locations. Ansh Lamba, what is this meta store? Shh, we'll tell you, don't worry. So this is my region. I can simply click on review plus create, and just remember I have picked South Central US. Okay, because I'll be putting all my resources under this location. Do we actually need to worry about location? Not really, because you are just using free account. So take a chill pill, bro. Just click on this home button. Just click on this home button, and then obviously in the recents tab you can just see your resource group if you have clicked on it. And obviously if you have not clicked on it so far, click on resource group, and then just search for your resource group. In my case it is this one, RG Delta Lake. Then this is empty because we have not created any resource, right? Let me just quickly click on this create button, and it will just take me to the marketplace. So first of all, I will simply write storage account, which is my data lake. By the way, you cannot create data lake, just select this one. Okay, you cannot create a data lake with Microsoft Azure. No, I'm not kidding. So the thing is, you need to just do one small step in order to create Delta Lake. Otherwise, it will create blob storage. Wow. So we just need to pick the storage account name. So you can just pick any storage account name, but it should be unique. So if I'm just picking my storage account name right now, so you cannot pick the same. And by the way, why you need to just pick my name? Because I just put my name at the end of my data lake or storage account. So if you love me a lot, you can just put my name in the beginning. Just kidding. Just put your name, bro. So I will simply say storage Delta Lake if it is available. Oh, it is not available. See, it is already taken. So I will just put my name because Ansh Lamba is not taken. Bro, you are in different mood today. Yeah. So I'll say I have simply mentioned storage Delta Lake Ansh. You can just put Ansh storage Delta Lake. Just kidding. You can just put your name. Okay. Storage Delta Lake Ansh. So then we just need to pick standard premium. We can just pick standard performance. Then redundancy option, I will just simply pick LRS. It is the cheapest one. If you are using free account, you do not need to worry, but your manager will really be happy when you just tell him that I have picked LRS because it will save you a lot of cost. So then go to next. Then this is the setting that you need to enable, that is hierarchical namespace. So just simply check this box and then it will just create the data lake for you. Then everything is fine. Simply click on review plus create and within few seconds your data lake will be ready. Click on create. Simple, 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 simple. Just do it quickly, bro. Do it quickly. So deployment is in progress. It will just take few seconds. So now we can just create Databricks workspace. Why I have picked Databricks workspace with Azure? Because I could have taken, truly speaking, I could have taken Databricks Community Edition as well, but I wanted to show you all the functionalities and I wanted to show, like, I want you to learn everything, and you can only learn everything if you are just working with Azure or like any cloud platform, but it should be a cloud platform instead of just Community Edition. You cannot learn everything with Community Edition. Community Edition is very good if you are just practicing your Pyspark coding and all, then it's really good. But in terms of like actually you seeing like how we can just do all these steps, it should always be linked to a cloud account. Okay, now I can simply go to resource. Okay, and then I can just go to containers and I can see my containers are empty. I can create one container in my data lake. It can be anything, let's say raw. That's a generic container everyone creates. Okay, and then I will create one more container that is called metastore. You will actually know about it because when we will be creating Databricks workspace, so we will just assign that container to Databricks workspace. We do not worry, we do not need to just cover Databricks in detail because we are covering Delta Lake in detail, and obviously it is with Databricks, so you will just learn much about Databricks as well, like on the way, but it's not about Databricks, it's about Delta Lake. Okay, so I can just simply say metastore. Okay, I will simply click on create. So I will just use this container to assign it to my Databricks workspace, which Databricks will be using. That's it. Okay, now I can simply go to home. I can simply click on my resource group, then click on create, then click on data, like not click on, just search Databricks. Okay, click on this Azure. So now you need to just pick the workspace name, workspace name. So in my case, I can simply say Delta Lake ADBWS, simple, like Delta Lake Azure Databricks Workspace, and region I can simply pick, let's pick West US. Simple, yep. So in order to work with Unity Catalog, we simply need to just pick the premium workspace, and instead of just picking premium workspace, I can simply pick like trial premium 14 days free DBUs. So, and if you're just using free Azure account, you can just pick premium. So it's all up to you. So I can simply pick role-based premium workspace and manage resource group. This is the resource group that Databricks uses to manage the resources such as manage data for managed tables and all. So I will simply say managed RG Delta ADB. Like you can just give any name because you will not be using it. So now simply click on review plus create and then click on create. So now it will just take like few minutes and then it will just deploy your Databricks workspace. And once it is deployed, then we can just see how to create everything. Everything means everything. So as you can see, our Azure Databricks workspace is deployed finally. So just click on this go to resource button and then we will just launch our workspace. Click on this launch workspace button. So welcome to Azure Databricks workspace. Don't worry, I'm not a brand ambassador of Databricks for now. Yeah, I don't know about future, but yeah, for now, no. So this is your Azure Databricks workspace and I love Databricks. So basically, this is the main tab, or you can say the area where you will be working 99.99% of the time. So just to give you a quick overview, and I know like you will be familiar with it. So basically this is the workspace where we just creating folders, notebooks, everything. So we just manage like all the resources there, right? Okay, then obviously recent tab, as the name suggests, all the recent notebooks, workflows, everything will be there. Catalog, this is the most important thing that we're gonna talk about it right now. Then workflows, yes, so you can just build ETL pipelines using workflows as well, very good. Compute, The most important thing, compute. We need a cluster to work with. Okay, simple. Then this is the area where you can just build SQL queries, dashboards, everything. And let me just tell you, you will feel exactly same as you're working with PostgreSQL, MySQL, MS SQL Server. So this is the perfect UI for those who want to use SQL queries in Databricks. Perfect spot. Then data engineering. Oh, I just spot one superstar here. Delta Live tables. Don't worry, we will be just talking about Delta Live tables. And this is the most recent topic. That is why it is a hot topic. So don't worry, we will cover that as well. Then job runs, where we can just track all the and where we can just monitor all the pipelines. Okay. So this is the like overview of Databricks. So now the most important thing. Now I will just click on this catalog button. Okay. And this is my catalog. So basically data catalog is the area where you create your databases, schemas, tables. So it stores all that information, right? So we gonna cover this area using Unity catalog. So as you can see, the legacy one is Hive Metastore. We do not want to use this catalog. I want to use Unity catalog for that. And how you can do this? Just a small step, just a small step. You need to create one Unity Metastore. What's that? It's called Unity Metastore. Okay. So it's called Unity Metastore. We will be creating Unity Metastore and then we will attach this workspace with this Unity Metastore and then our Unity catalog will be enabled. Okay. So for that, just go to this Microsoft Azure button. Okay. And this is the home page, obviously. Now you need to go to Microsoft Azure Databricks console page in order to create Metastore. So how you can just go there, click on this drop down and then you will see manage account button. Now hold on my bro, hold on. So the thing is, we are not covering Databricks in detail. We are using Databricks as a platform to access Delta Lake. If you want to learn Databricks in detail means in detail, I have created dedicated video on Databricks course and I have covered everything in that. I have covered Unity catalog. I have covered everything. Everything means everything. So you can definitely watch that video. So is that video a prerequisite for this one? Definitely no. But after learning this Delta Lake, you should know all the functionalities of Databricks because both go hand in hand. You cannot say like I know Delta Lake but I don't know Databricks. That's a foolish thing to say. So you need, because obviously they are the creators of Delta Lake, right? And you need to learn Databricks in detail as well. And in order to just learn Unity catalog in detail, then definitely, because in that course I have followed everything with Unity catalog approach. Okay, so if you are not familiar much with Unity catalog, you can follow my steps right now, but it's your duty, because that's why I just put that prerequisite. You want to crack your dream job, and if you want to crack your dream job, dream company, you should know each and everything. So if you are not familiar with Unity catalog, you can just follow my steps right now how I'm doing it, but promise me, after watching this video you will be watching Databricks Unity catalog video as well. Just click on the video that is coming on the screen right now. I will just attach the video link in the I button and in the description as well. Just click on that video, click on the like button so that it can just go to your saved library like videos. Now Ansh Lamba, why will be liking it? Okay bro, do not like that. Just click on that video and just save it in your playlist. It's your choice, but let me just tell you, you're gonna love that video. It's not just about liking that video, you're gonna love that video. So let's see how we can just do this. So now, if you are not able to see here manage account button, I have also covered this step in that particular video. You can just see when I'm just creating Unity Metastore, I have covered this part there as well. So you can just watch this like how I'm going to cover. So okay, let me just tell you as well. So this manage account button, sometime it will not appear in your case. So what you need to do, you simply need to go on Google and just type accounts.azuredatabricks.net. Simply click on this and you just need to hit enter. Then it will ask you to provide the enter ID. Okay, so in your case it will be, just go to home, just go to Microsoft enter ID, then just go to users, then just select your user, and then you just need to put this hashtag email ID and then just put it there and just reset your password and just put it there. That's it. Then you will be entered into the manage account. Let me just show you how it looks like. So this is your account console page. Perfect. So as you can just click on this, your name, and you will see that you are logged in with your hashtag email account instead of your normal email account. Okay, so do not need to worry. So I'll just tell you how you can just do this. So first of all, if you want to see that manage account button under your normal account, simply go to user management, and just add that email ID under your admin, and then just add that person, that email, that is your email, as account admin. Then you will be able to see that manage account button under your normal email. Sorted. Okay, let's create now the meta store. As I just clicked on catalog button, I have already some meta stores ready. Okay, so just ignore these two meta stores. These are like my previous meta stores that I created. Okay, so this is the new one. Now your Databricks automatically creates one meta store for us. Okay, so now do I really need to use it? It's up to me. I will definitely click on this delete button. I will just click on this, then I will just click on this delete button. Why? Because I want you to learn how to create your own meta store. Simply copy the name because it says first put the name, then I will only delete it. Okay, bro, get lost. So I will create my own meta store because I can just show you all the steps required to actually create the meta store, because in the real world you will be creating your own meta store. Okay, simply click on this create meta store, and then you just need to name your meta store. So I will simply name my meta store is delta meta. Yes. And region I'll be picking as West US. West US. Perfect. Now it is asking us to provide the ADLS Gen 2 path and access connector ID. So basically, if you are familiar with Unity Metastore or any Metastore, it's not about Unity Metastore, it's about Hive Metastore, anything, right? So the thing is, Azure Databricks or Databricks Workspace uses an account, a storage account, where it keeps the data, for managed tables and everything, right? So that's why we created the meta store container, so that we can feed this container here. So what it will be doing, so let's say if I create managed table, okay, and obviously in case of managed table, Databricks manages the data, we do not manage the data. So in that particular scenario, Databricks will keep the data there in that container. So we are dedicating that container to Databricks. So we already know the location. So the location is, I think, we just need to pick the container name. Container name is metastore @storage. Storage delta lake Ansh .dfs .core .windows .net. How do I remember this location? With the course of time, you will also remember it. Don't worry. Okay, like it's just a common syntax. Then we need to pick the access connector ID. What is this thing, Ansh Lamba? We haven't heard about this thing. So let me just tell you, then you will hear it. So basically, let's say you are just using your data lake. What about, let's say you are using ADLS Gen 2, okay, and this is your Azure Databricks workspace. So in order to use this ADLS Gen 2, you need a connector. And it's called access connector. So let's say this is access connector. So what exactly we will be doing? We will create this access connector, this one, okay, and we will say just add the role of a contributor to this storage account, okay, and then we will use this access connector in ADB. So indirectly we can use ADLS Gen 2 through this access connector. Simple. If you want to make it complex, you can just add anything to this definition, but this is the simplest way to explain it. Okay, and we want simple things in life. Life is already very complex. Okay, so this is all the things that we need to do right now. So we will simply go to Azure and we can create one access connector ID. Pick your resource group, then click on create, and now we will say access connector. Oops, sorry. Click on access connector for Azure Databricks. Simply click on this, click on create. Okay, and then one name. So obviously you can put my name if you're obsessed with me, if you love me. Access, Ansh access. Is it available? Access con. Oh, it is available. Okay, so I will simply click on review plus create and simply click on create. So it will just take few seconds to create this access connector. And what I will do, I will assign the role of a storage blob contributor to this particular access connector. Okay, it is done. It's so quick. Click on home, click on this resource group, click on this storage. Let me just refresh first. I should see that access connector. Perfect. Perfect. Simply click on this storage account and click on containers. Not containers, not containers. Click on this access IAM. So we will define the role, add role assignment, and then we will search storage blob contributor, storage blob data contributor. Click on this, click on next. Then we need to assign this role to manage identity, which is access connector. Where is this? Click on this. Then you need to search. I will simply pick Ansh access connector. Click on select, click on review plus create, review plus assign. It will just take few seconds. It's done. It's done, bro. It's done. Simply go to resource group. Now you just need to copy the resource ID. So simply go to your access connector and then just copy this resource ID and then just go to your console page. So I can just paste the access connector ID here and everything is done. Simply click on create and everything should be fine, and it will take just few seconds and everything is done. Okay, so now we need to just quickly go to this workspace or just this catalog, and then you will see your new Unity Metastore. Okay, then you will see the workspaces. Simply click on it and then you will see there's no workspace assigned right now, so you can just simply click on assign to workspace, and then you just need to pick this workspace and then click on assign. Simple. Click on enable and done. Now one more thing that you need to do, under configuration you need to just pick the edit button. So just click on this and now you will see your hashtag account is created as created as admin. So we need to pick our normal account, which is the normal Gmail account, because we are using Databricks with that account. Okay, so simply click on save, because only then you can just create Unity catalogs within that. So everything is done. Everything is done. Now we can just simply go back to our Databricks workspace. So Unity Metastore is enabled. Unity catalog is enabled. Congratulations. Congratulations. These are all the workarounds, not workarounds, like groundwork that you need to do. And these all are important if you are saying that you are experienced with Databricks, you are experienced with Delta Lake, you need to do all these steps. So that's why I picked cloud platform to actually show you all these steps. Otherwise, how you can be competitive, bro? You are my data fam. You are representing me. You are representing us. You are not just representing you. You are representing our whole community. Okay, so be competitive. So basically everything is done. So we will simply go to compute first and we will create our cluster. Okay, simply click on create compute and then it's very easy. Pick the policy as personal compute, because and click on confirm, because we will not be using like much computation to process the data. So simply click on personal compute, and as you can see here, you can see the Unity catalog here in your cluster. So that is required. Okay, then runtime, we will simply pick 15.4 LTS and node type is fine, DS3v2. Inactivity, I would say 20 minutes, and done. Click on create compute. It is done. It will take few minutes because it creates the virtual machine actually in our managed resource group. So it will take few minutes, but we have some work to do. I will simply go to catalog and I will simply create my catalog now. Okay, so what will be my catalog? Click on plus and add a catalog. What will be the catalog name? So catalog name, I will pick Delta catalog. Perfect. Type standard. Perfect. And then storage location, no. We need to create manage catalog because it can just take the location of Metastore. Okay. Click on create, done. Oh, configure catalog. Catalog has been created. Recommended click configure to additional permission. This configure catalog. And then this access. So it is just asking you to just granting the access to other users and all. So as you can see, if you just see workspace, all workspaces have access. What does it mean? So as we know that we have connected this workspace to our Metastore, if we connect multiple workspaces, so all those workspaces will be having the access to this workspace. We can just keep it or we can just remove it. For now, it is fine. Owner is Ansh Lamba easy. And then grant permissions. So we can just say like principal user, all account users has this access. So for now, it is fine because I'm using it. Click on next. Then metadata, it is fine. We do not need to define anything else because key value pair is just for like categorizing it, and we do not need to do that. Click on save. It is fine. Okay. So now as you can see, delta catalog is done. Delta catalog is created. So now we need to click on this catalog button. Now we need to click on this external data. Why? Because we will be writing everything with Databricks under this storage account and under this raw container. So we need to define the external location. Obviously, it is very basic thing that if you want to write some data to external location, you need to define that location, right? So we will be just quickly creating external location, and it's just a matter of few seconds. Click on external data, click on create external location. Actually, you can create external location using code as well. Like it takes like 3 to 4 lines of code. It's not a big thing, but it's always good to just create it through UI. It's really fast and it's interactive. So external location name, I will simply say ext data lake. Simple, because obviously I do not need to use this name, but it's just for the identification. URL, now I need to just put the URL. So I will put the whole URL abfss, and my container name is raw @ and obviously storage account name storage delta lake ansh .dfs.co windows.net. By the way, all these things are covered in detail in that video, so that's what I'm saying. You, if you just watch the, if you follow these steps, you do not need to worry, just follow these steps. But promise me, after learning delta lake, you will just understand all these steps in detail. Okay, okay, and I trust you, you will do that. So now we need to also pick the storage credential. So storage credential is nothing but that connector ID. So we can just pick that, and if you do not have one, you can just quickly create one. And credential type is Azure Manager Identity. Access Connector ID, you can just go back to Azure and just copy that ID again. Access Connector. All of these are fundamentals. All of these are fundamentals, like how you can just build the connection and why you need to build that connection, why you need to build the external location, why. Ansh Lamba is talking about that. See, I do care about you so much. Simply click on create, and then it will just create the external location for you, and done. Now we are good to go. Now we are good to start building our notebook and everything. And let me see if my computer is ready. So our cluster is also ready. So let's start working with our cluster. And for that, let's simply go to workspace and let's create a workspace. Simply click on workspace again and create a folder. So we will create a folder. Yes, here it is. So I will just name it as Delta Lake tutorial. Okay, let's hit enter and then create a notebook. Okay, perfect. So now this is our notebook. This is our Databricks notebook. So without delaying much, let me just rename my notebook. So first of all, I will say one Delta Lake, because this is the first notebook that we are creating for Delta Lake. Okay. And if we, and if we want to just create more and more, then we will say 2, 3 and many more. Okay. Then the second step is connecting our Databricks workspace, Databricks notebook with cluster. Okay. Simply select your cluster. Perfect. Now I will simply use my magic command. Again, I'm repeating, if you want to learn Databricks in detail, just check the video that I just mentioned about and you're good to go. So we are just simply creating a markdown, which is just a heading. Okay. So I will simply say creating a delta table. First of all, we will create a delta table. Okay. So how we can create a delta table? It's exactly same as we create delta table in SQL. Not exactly same, but yeah, the syntax is exactly same, but we need to do some things because we are creating an external delta table. Okay, creating an, let's create a managed table first. Okay, so I will say create a delta table managed table. Perfect. So if you are not aware of what is managed table and what is external table, so let me just tell you what's the difference between two. So let's suppose this is our managed delta table. Okay, what is managed delta table? You will know, bro. Just hold on. So basically, this is our metastore, and in our case, we are using Unity metastore, right? So let's say this is our Unity metastore. Number one, this is our cloud storage. This is default cloud storage. In terms of Unity Metalog, Unity Metalog, wow, Unity Catalog, we will be using default location that is assigned to the Unity Metastore, and in our scenario, it is the Metastore container. It is the Metastore container name, and within that, it will save all the default files, right? Perfect. So that's why I was telling that all the data for managed tables will be stored in that particular container. Perfect. So now let's say I create one table. Let's say this is my table. Okay. And this table name is such as orders. Let's say this table name is orders. So this orders table will be stored in the metastore. When I say this orders table, I mean to say the metadata, table name, column name. That's it. That's it. Or you can say just the table definition, metadata of the table. Like this is the managed table, this is or an external table, the table name and under which schema it is registered. So all the table definition will be stored in the metastore, but the actual data will go to the default storage location, and in our scenario it is metastore container. Okay, I will show you, don't worry, I will show you when we will be creating the managed table, it will go to that particular container. So this will go here directly. So the difference is when I say delete this table, if I give command delete, then it will be removed from this metastore, obviously, but this will be removed from here as well. I know data is sitting in the cloud location, but still it will be removed. Why? Because it is managed by Databricks, so it will remove the data as well. Okay, but in case of external table, if I just create table, same table, orders, okay, orders table, and I create this external table, that means I want to store this data under my own cloud storage. It can be anything. In our scenario, it is the raw container. It is the raw container, or it can be any container. It can be any storage account. External table means we need to store the data as well anywhere. Okay. In our scenario, it is the raw container. Okay. Then what will happen? Then when I will say delete, then this table which is stored here as orders, and here is the data. So this will be deleted from metastore, obviously, but this time this data will not be deleted from cloud storage because this is my own cloud storage. This is my own cloud platform that I'm using to store the data. Simple. So let me just show you practically as well. So this is the creating delta table, and before that actually we need to just create the schema as well, because under catalog, if I just click on this button catalog, you will see our catalog, right? Let me just see, this is delta catalog. Within this we do not have any database means like any schema, so we can also create schema here first. So I'll simply create one more cell above this, and I will simply say create schema, and schema name can be let's say bronze, or raw schema, let's say raw schema. Okay, and I need to assign the schema under delta catalog. Perfect. Okay, so this is the prerequisite, obviously, and I can just create one more code cell, and I will just give one heading, and I can say create schema. Perfect. So let's run this first. And if you just want more space in your Databricks workspace, you can just click on these three bars and you will have more space. So now it is done. Our schema is created, as you can see. Okay, our schema is created. Now what I will do, let me just increase the size if it is fine. Yeah. So now what I will do, I will simply create a managed table. How we can do that? Let me just show you. Let's say I said create table, and then I need to define the catalog. In our scenario, it is delta catalog. Then we need to just say schema name, in our scenario it is raw. Then I want to say managed table, so I will simply say managed table. It is the table name, you can just give any name. I'm just giving managed table so that it is easy to find. Okay, let me just see, let me just say managed my table, so that you won't be confused that is this the syntax. No, this is any name, this can be any name. Okay, create table, table name. Then we just need to define the ddl command to define the schema. Same way, id int, then I can say, let's say order name. Okay, and I will simply say string. Then let's say I want to say amount. Okay, and this can be int, or let's say double. Okay, then I can say product id, and I can say int. Okay, so this is done, this is done. Now we need to tell using which format we need to create table. And as we know that we are using delta format, so we will simply say using delta. So now this step is optional, because if you if you do not define any format, it will take delta as by default table format. But it is always good to just define the format, it promotes readability. So it's up to you. I always define using delta thing. Okay, so now it is giving us some suggestions, so ignore it, I will just tell you. So now if I just run this command, it will, bro, I told you, just go away. So if I just run this command, like run this cell, so this will create a managed delta table for me. It will create a managed delta table for me. Okay, so now I will just run this command, because I'm not defining any location. That means it will be a managed table. Okay, let me just run this. Okay, it is just creating that table, and it will take just few seconds. Just hold on. So till the time it is created, yeah, so now you can see it is in progress, and it is almost done. Almost done. Perfect, perfect. So now I will just insert some data. Insert into. Okay, insert into, and table name I will just copy it from here. Okay, then I will say values. This is exactly same as SQL, right? Values. So I can simply say id as 1, then order name, let's say biscuits. That's it. It can be anything, right? Then amount can be, let's say, $10, and prod id is 101. Simple. And similarly, I can just put more data, and let's say I want to pick this time noodles. I'm really hungry, so maybe that's why I'm just getting these suggestions. And it can be 102, and then let's say order id 3. Again, I got biscuits, and then this time 20. Why? Because the guy or girl purchased expensive biscuits. Then prod id is just like, let's say, 103. Okay, so this is data. I just need to insert this data. This is just a random data. Okay, do not take it to your heart. So I'm just running this command, and I'm just inserting this data. So now you will see, like, it is exactly same as SQL. What is the difference, bro? We are creating all these tables without actually having any kind of traditional database. Everything is stored in the form of files. I will just show you everything, don't worry. Okay, so now I will simply query this, because I want to see the data. Select asterisk from delta catalog dot raw dot managed my table. Okay, let me run this. So this will give me the data table that we have created. Perfect. It is giving me the data in the form of like structured table, right? But actually, do you really know how this data is stored? And where it is stored? Let me just show you. So as I just mentioned that if I create a managed table, it will be storing the real data. Real data means the delta format data in its storage location, which is the default storage. So what is the default storage location? Let me just show you. If I just go to catalog, okay, then if I just go to, if I just refresh it, okay, if I just go to raw, then this is my table, okay, and then if I just click on it, this is the metadata. This is the metadata. Okay, now just go back to this 3 bars and click on catalog, and now just search your catalog, this one, raw, and this table name. Perfect. Now this is the detailed panel that we get, right? So now as you can see, everything is written here. Just go to details, and here is the storage location mentioned. So what I mentioned in the definition, that it will be using metastore. This is the default container. I didn't give any location. It automatically picked that location. Why? Because we defined this location in the Unity catalog. And what is the folder name inside this? This is the folder name, and this is for our schema. This is the table ID, which is for our managed table. So if you really want to see the data, I can just show you. If we go back to our Azure portal account, go back to home, then RG Delta Lake, then storage Delta Lake Ansh, and then within containers, you can go to Metastore. And then within this is our schema ID, click on this. Within tables, this is our table ID, click on this. I'm clicking on this, you will see that actually it is a file instead of a traditional SQL database. This is the Delta Lake. This is the Delta Lake. So as I just mentioned in the definition, you get data in the form of packet. So this is your packet format file. Perfect. And this is your Delta log that is created automatically because we told Databricks to create a Delta table. Got it? Got it? And if I just click on this Delta log, by the way, I will just show you Delta log in detail. Don't worry, because we need to do some more transactions so that you can actually read those logs. So this was all about the managed Delta table. Let's create an external one. So I can simply go to Databricks, and I can simply go to recents because I just need to open my notebook again. So let's create an external Delta table. Okay. So I will simply say everything will be same, but this time we just need to do one more thing in order to create the external Delta table. Okay. So I will simply first of all put the heading, and I will simply say create a Delta table external table. Okay, perfect. So now I will just copy the steps here. Simple. I have just copied it. So oops, copy it and then paste it here. Perfect. So now Ansh, Lamba, everything is same. So why this time it will create an external table? First of all, I just need to rename it. I will simply say external table. Okay, this is my name that I want to give. So Ansh, Lamba, everything is same. Why it will create an external table? You know the reason? Let me just tell you. Because this time I will simply say location, and I will define the location as well. ABFSS, and I want to save in raw storage Ansh, storage delta Ansh, storage delta lake, I think. Yep, storage delta lake Ansh dot dfs dot core dot windows dot net, and within this I want to create a folder called external table. Then if I run this command, I am telling Databricks to create my delta table to this particular location, to this location, to this location. So this is an external table. Let me just run this, and it will create the delta lake table to this location. And now I will just insert some data. Okay, so this is my data that I want to insert, and this time I obviously need to just change ext table. Perfect. Let me just run this. So this is done. Let me just query this as well. So obviously we will see the same results. Okay, so there's no difference, but you will see the difference this time. Really? Yes, really. Let me just run this. So this is our data, right? But now this time I can actually manage the data because it is an external table. So if I just go to my Azure storage, if I just go to containers, so this time my data is sitting here in my own storage account, in my own container. Just go here. This is your table name. Perfect. Click here. And this is your data of delta table, external delta table. Perfect. Perfect, perfect, perfect. Sorted, 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 sorted. So this is your data. Now I can, I want to show you one more thing. What's that? Let me just show you. One way of querying this data is referencing the table. Obviously, what is the second way of doing it? So the second way of doing it is just say select asterisk from delta dot, then these are the ticks. These are not single quotes. So these are the ticks that is available just right after the tab button, like just above the tab button. So now I will just give the location, and the location is this one. So what I'm saying, I'm saying that select asterisk from this particular location, and now I'm not even referencing any kind of table. Still I can see the data in the structured format. That's the power of Delta Lake. Simply run this and you will see exactly same data. See, querying files, just write it in your notebook. Querying files using select. Perfect, 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 perfect. So now let me just show you what are the other ways of creating delta tables. So one of the very famous way is, like, you would have heard about this. So it's called CETAS, that is create external table as select. So this is very popular command. So let's say you want to create one more table using the existing table. How you can do that? So I will simply say create table and external, oh sorry, delta catalog dot schema is raw, and then I will say external table CTAS or CETAS. Okay. So what I will do, I will create this table and I will say as, and then I will simply say select asterisk from this table, uh, this table, which is just ext table that we have just created. So it will just create this table, and obviously if we want to define like what will be the, let's say, location, what will be the format, then we can obviously define. So we can simply say using delta and location only if you want to create external table, and in real world we create external tables. So this will be my location, external table CTAS. Let me just run this and it will simply create. So it is taking some time. Yeah, perfect. So it has created us this table without writing any DDL command, without inserting any data manually. We have just copied the data from one table to another and we have created the new table. I know you are excited to see the data in physical format. So let me just show you. If I just go to raw container, if I just refresh it, I should see another table. Perfect. And it should also follow everything like delta log and packet file, everything. Perfect, perfect, perfect. So I have everything ready here in the delta format and all data is copied. Perfect. CETAS is like very popular command and it's very powerful. Some other ways are also there, like cloning, deep clone and shallow clone. I can also show you that as well, because it is very popular and very much in demand, because it's a kind of new feature. So for that I will simply create one heading. Okay, I'll simply say cloning in Delta Lake. Okay, so we can just create clone tables. Okay, so for that it is very simple. So I will simply say create table delta catalog dot raw dot ext table deep clone. So there are basically two types of cloning. So I will show, wait bro, wait. So I will show like both the ways. So first of all, let me just create another heading and I will say I will just make it bold and I will say deep clone. Okay, so this is a deep cloning in uh, Delta Lake. What is the difference? What is the difference? So when we say deep clone, that means, let's say this is our source, this is our destination. So in this scenario, obviously if we are cloning a delta table, we have something called as delta log and the file. So in this particular scenario, it will copy everything here. Everything means including this delta log, including this file as well, including the physical real data as well. So it will just create a delta log, okay, having all the metadata of the data and the data as well. That's called deep cloning. So how we can just create deep clone? So it is very simple. So here we will write deep clone, and from where we need to just create the clone. So this is the table name. I will pick it from external table. Yeah, perfect. So this is my command. If I just create, now you will say, can we create external deep clone? Like if I want to create a clone table and I want to store it externally. So far I don't think so this is available. So if it is updated, I don't know, but I don't think so we can create external tables. We can only create manage clone tables. So I'll simply run it, and don't worry, in case of manage tables as well, we can see the data. That's the power of Unity Catalog, right? We can just go inside the storage account name and we can just check the metastore container and we can just see the data. Don't worry. Okay, and I will show you the difference as well. So in this scenario, you will see the data as well. Okay, so this is done, this is done, this is our done, like this case is done. Now I will show you the shallow clone and then I will show you the data. So I will simply copy this code and I will simply say, I will simply write it here, %md, and let me just say shallow clone. Perfect. And then let me just write it, and the only difference is I just need to write it here shallow. Perfect. Let me just run this. Okay. Oops. Oh, like we can only create like shallow clone in case of the source, if the source is like managed table. But in our scenario, we have managed table as well, bro. Why you are worrying so much? Managed table. What was the name of that table? Let me just check. That we created inside raw. It's called managed my table. Perfect. Perfect. Let me just make the clone of this table. Already exist. Oh, thank you so much. I need to just rename this as well. I forgot to mention it. So okay, perfect. So it is just creating a new table called external table shallow. By the way, it's not external table, it's managed, but it's just the name of the table. Shallow, and other table is external table deep. Let me just show you both the data. Okay. Let me just click on these three bars and click on catalog. Then I will simply refresh it. Okay. Then I will simply click on Delta catalog and raw schema. And within this, I will see all the tables. So I want to just compare shallow and deep. I will first click on this deep and go to details. And this is my table ID. Okay. 8751 is for deep. Remember it. And what is it for shallow? Go to details. It's called B5 something. Okay. Let's go to our storage account. Let's go to containers and metastore. This is our schema. These are our all the tables. So as we just saw that this is for deep clone. So when I just click on this, I should see delta log plus the files. Let me just click on it. Perfect. Delta log plus files. Perfect. If I click on the other one, this one, B5, I should only see the delta log. Perfect. So now Ansh Lamba, if only delta log is here and there is no data, so if we just query the data, should we see the data? Yes. But how? Because in this delta log, it is written that read the data from, just tell me, from where? From here, this table. So if any partition is there, it will just read the data. Perfect. Perfect, perfect, perfect. Now, one interview question. If I just change the data in this particular table, in this part, if I just add the data, let's say, so will this get affected? Yes. Yes, yes, yes. Really? The answer is yes or no, because if we remove the partitions, if we remove the file, then it will create the problem. Otherwise, no. You will get to know why, because you will be just exploring delta log in detail. Now, second question is, if we just talk about deep clone, will it create any problem if I just change anything in the source? The answer is 100% no, because we have just copied the data as well. Now our table is an independent table. It has no link with that particular table. So in that particular scenario, it is always advised, like it is a good advice to always create a deep clone. But obviously it all depends upon the requirements. Okay, so this was all about the basic operations that we do in delta tables, creating, inserting data, creating tables using different ways. So now we gonna see something different, and we gonna see DML in Delta Lake. DML in Delta Lake. So okay, let me create a second notebook for that. Okay, so let me just go to file, not file. Let me just click on these three bars and go to workspace and workspace Delta Lake tutorial. Let me create the second notebook. I will simply say new notebook, and I will create a new notebook, and I will say second Delta Lake. Perfect, 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 perfect. And I will connect this notebook to my cluster, obviously, and I will put the heading as %md, and I will simply say DML with delta tables. Perfect. What is like DML? What is DML? What do you think? So DML consists of, um, let's say in update, delete, like all these operations. If you want to perform, like what will happen if we update any data, what will happen if we delete any data, what will happen if we just remove some data, or like drop the entire table, what will happen? We will answer all the questions, and for that we need to do one small thing, that is called turn off, not the mobile phone, don't worry, turn off the deletion vectors. Why? Yes, we need to turn off the deletion vectors first. Why? Because if you want to understand all the concepts, like how things are happening, how things are like actually being placed, and how it was like behaving before deletion vectors, so we first need to turn off the deletion vectors. Then I will explain you like how things are happening. Then we will understand the deletion vectors, and now at this moment I will tell you how it is improved now, like how deletion vectors are making a big difference in terms of storage cost optimization. Okay, so for that we will like quickly turn off the deletion vectors, and let's start with our DML with delta tables. And then when we will reach the to the chapter called deletion vectors, then we will explain everything, okay, about deletion vectors. So do not need to worry about that. So just keep this word in your mind for now. That's it, that is good enough. So let's see. So first of all, let's create a new table, and obviously you will be creating an external table. So I can simply go to recents tab, and I can just copy the code that we use to create external table. It will save us a lot of time, right? Because we do not need to perform the redundant steps. So copy, and I can simply right click on it, open link in new tab, so that I can just parallelly do all the stuff. So Delta Lake, and here. So we will create a new table, and we will call it as, let's say, ext table DML. Okay, DML, and I will save this table here. Let's create this. Perfect, perfect. Okay, and let me just insert the data into this. Okay, let me just insert the data, and I want to insert data in DML. Perfect. So now this table is created and we have the data. So now we will be turning off the deletion vectors, and for that I will simply first create the heading. and I will simply say turning off the deletion vectors. Okay, simple. So first of all, you will turn off the deletion vectors, and for that you can simply search deletion vectors, like deletion vectors delta lake, and then you can just copy the code from there. So actually, do not worry, we will just discuss deletion vectors in detail, so do not need to worry. So I will simply copy this code. So actually this code was being used to enable the deletion vectors, but now Databricks has auto enabled this feature in all the upcoming Databricks workspaces. So it's good, it's good, like it's auto enabled in the all the latest versions of Delta. So that's why we now need to use this code to turn it off, because it is auto enabled. So I will simply go to my this notebook, and I will simply say alter table, and I will put my table name, which is delta catalog dot raw dot ext table dml. Okay, perfect. And I will simply say false. Perfect, 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 perfect. So it will just turn off. Now it is turned off. Okay, now let's perform any dml command. Let's say I want to perform update. Okay, I want to perform update. Let's perform update. So I will simply say update in delta tables. Okay, let's perform this. So in order to perform update, it is exactly same as you perform in SQL. So I will simply say, first of all, I can just pick SQL. Okay, so update, and then I will simply type my table name. So it has already given us the recommendation. So thank you so much. Oh, another recommendation. It will save us a lot of time. Okay, simply hit tab. Okay, so now what it is saying just set the amount equals to 30 where ID equals to 1. This can be the scenario, right, where we just need to fix the amount. Maybe we have just put the amount wrong. Earlier we had amount equals to 10, if you remember, and now we can just pick the amount as 30. Okay, this can be the like normal update. Okay, let me just run this, and I believe that you are smart enough, you know what will be the output of it. If I just run the select query now on my table, select asterisk from delta catalog dot raw dot extdml. Now we'll say, hey Ansh, we know it will just change the price to 30, and earlier it was 10. It was so simple. Like, what's the big deal? The big deal is with the actual changes that it has done. What do I mean? Let me just show you. So if I just go to my raw folder, like raw container, and if I just go to my raw container, and if I just refresh, obviously I know that we have this table. And if you remember, we always get one Parquet file and one delta log, right? And now we have updated some data which was stored in Parquet file format. So now what will be your expectation? What will be your expectation? Your expectation, I know, will be it will just update the data of that Parquet file. We all know that. Really? The answer is big no. Big no. Ansh, wait, hold on. Come here, boy, come here. Yes, yes, yes. What just happened? What just happened? So, this is called tombstoning. Tombstoning. Ansh Lamba, just tell us right now what actually happened right now. Okay. So the thing is, this was our previous file that was created when we inserted the data. How do I know? Obviously by looking at the time. It's 2:20, and oh, sorry, by 2:17. Like, this was the first file because it was created at 2:17. Okay, so this was the file. Okay, this was the file. Okay, and this was having all the three records: 1, 2, 3 ID and amount 10, 20, 30. Okay, Anshulamba. Okay, we were expecting that data will be changed here, but actually it is called tombstoning. Actually, what actually happened? So many actually. So what actually happened, it will not make any changes in this particular Parquet file data. It will not make any changes. Then what it will do? It will create a new Parquet file in which it will make all the changes, plus it will keep all the data that was already there. So this file will be used from now onwards, and this file will not be used from now onwards, and this file will be tombstoned. Tombstoned. This file will be tombstoned. Simple. So this file will be here. I will tell you why it will be here. Just hold on. This file will be here, but it will not be used by the table. Now, Mr. Ansh Lamba, how our table knows that which packet file to read and which not? That's a valid question. Because obviously this packet file also has 3 records. This packet file also has 3 records. But when we query the data, we only see 3 records. That means it is sure that it is only reading this file. But how it knows? The answer is in this small box. It is in delta log. Let me just click on this. So this is your delta log. Wow, wow, wow. So many files, so many files. First of all, we are only concerned with the JSON types. We are not concerned with the CRCs. So why we have CRC files? So basically CRC files are cyclic redundancy check files. Yeah, cyclic redundancy check files, which is there to just check if data was copied rightly and if everything is fine. So it is just for the monitoring. We can remove these files. Do not need to worry, but do not ever touch. You can touch, but you cannot do anything with any of the JSON file. Otherwise it will be a big mess. Why? As I just mentioned in the beginning, that delta log keeps all the transactions. So I will now show you each and every transaction. So initially it created this JSON 00.json. So it goes by sequence. So let me just click on it, and let me just click on this edit button so that I can just see the content. So it has created the table. So what we actually did for the first time, we created the table. That's it. We defined the metadata. So in this particular JSON file, it is written that we have created this metadata. That's it. Then in transaction 1, that is 00.json, 001.json, click on it, edit. It will say add this packet file, because we inserted the data and data was in the packet format. We all know, right? So it said insert this partition, and before applying any update, so we were seeing this data, right? 1 2 3, and amount was 10 20 30 something. Okay, with id equals to amount was equals to 10. Okay, simple. Now what we actually did after that, what we actually did, let me just click on this 2.json. So if I just click on edit button, it will say metadata thing. Like obviously if we are just applying any update, so it will just show that thing. Oh, so the thing is this one, metadata. So as we all know that we removed the deletion vector. Okay, so we actually changed the metadata. Okay, so metadata is like data about data, right? Data about table. So earlier it was referring deletion vector, but now we remove the deletion vector. So that transaction is also saved, yes. So this transaction is for this. Now the main transaction, this 3.json, just open this, just click on this edit button. Now here is the thing, I told you that it mentions all the information in the delta log, right? So just I let me just zoom it. Oop, 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 oop. Yeah, now you can see it has specifically mentioned in the delta log that remove this partition and add this partition, remove this partition and add this partition. That means the previous partition, the previous packet file is removed. When I say partition, I am actually referring to packet file, so do not get confused. Okay, so this packet file is removed and this is added, but it is not physically removed. It is removed in the delta log. Data will be there, but it will not be referred. It will not be referred. It will only refer the new one. Okay, okay, very good, very good. Just take the notes, okay. So this was the delta log. Now you know how it handles everything. Now you know whenever you just create or like let's say write any DML command, you know like what actually is happening. Now let me just show you, if you write any delete command, what will happen? And I want answer from you this time. Okay, so let's apply a delete this time. So I will simply say delete. Okay, another very common DML command, right? Delete. If I say delete from Ansh Lamba pick SQL, okay, delete from delta catalog raw.this table, and I want to say where id equals to 1. I want to delete that id. I want to delete that id. Okay, let me just run this. Now I want an answer from you. Okay, I want an answer from you, and I know that you can answer this question. Okay, now if I just go to my external DML table, okay, now why I can see this third partition? Why? Because I just removed the data. What is the answer? What is the answer? So if you were able to answer this question, very good, very good, very good, very good. If not, don't worry, now you know the reason. So you know that it was only referring this new partition file, like new packet file. Now you applied another delete, another DML. So what it will do, it will tombstone this packet file and will write everything like updated information in this packet file, and it will save this information in, correct, in delta log. Same way, like remove this and add this. Do you want to see? I can just show you. Delta log, and here we have new JSON file 04.json, and then edit, and then it said remove this partition and add this partition. So one interview question: when I go inside this delta log, how it will be reading my logs? Let's say I just queried the data. So will it only read the latest JSON file, which is 4.json? Answer is no. It will start reading from first, like 0, and it will go till the end, like the latest JSON file, and it will perform all the operations every time you will be querying the data. Yes. So you will be saying, Ansh Lamba, in future, let's say we have committed so many changes and we have like so many DML commands, how it can just read all the transaction, like all the JSON files? So the answer is, my friend, my bro, after creating 10 JSON files, after creating, here to me, here to me carefully, listen to me carefully. After creating 10 JSON files, it will create summary of all the JSON files into one. So it will combine all the 10 JSON files into one, and then the 11th one will just read one JSON file instead of 10. Okay, and then if I just add 10 more, so the 21st JSON file will read only one, because it has summary of all the past JSON files. Okay, sorted, simple. See, now you're growing. Now you're becoming ready for the interviews with the time. It is just the beginning. Hold on, bro. Hold on. Okay, so this was all about the DML commands in the Delta Lake. So now you all are well versed like how we need to do the things. Now, here is the game changing thing. What if we turn on the deletion vectors? What will happen? What will happen? Do you really want to know what will happen? Do you really want to know? So let's create a clone of this notebook, and this time we will perform everything same, so that you can relate. Okay, and we will not turn off our deletion vectors. And now I will show you what will happen and how deletion vector is like so powerful, and which actually saves a lot of cost, storage cost. Do you really want to see? Let me just show you. So I will simply go to my workspace. Okay, and then I will create a clone of this notebook, the second one. Okay, clone, and I will name it as 3. Okay, 3, and done. Clone is ready, and I will just simply click on it, and I will connect this notebook to my cluster, obviously, and we will say, we will create a new table. We will say DML dv, deletion vector, let's say. Okay, dv, and obviously we need to save it in a new folder, dv. Let's create this. Okay, and let me just insert some data inside this dv. Okay, perfect. Now I will just delete this cell. Or I can just say not turning off the deletion vectors, because now I am going to explain you the concept of deletion vectors, and this lovely documentation is waiting for all of us. So sorry, we have to delete this cell. Okay, now before turning on the deletion vector, I want to show you the folder that it has created for us in the row. And as you can see, this is the folder, and it will just have one Parquet file. We all know now. Okay, now I will perform an update in this delta table, the same update, same. Okay, I will simply say dv. Okay, let me just do this. Okay, it is done. Almost done. Okay, then I can just query it. Obviously, it will just change the amount from 10 to 30. Everything is fine. Everything is fine, bro. Everything is fine. Now. If I just click on this, refresh button, what will happen? You will say, Ansh, we are smart now. We know that it will just create another Parquet file, and it will just tombstone this one, and it will refer this one. Really? Let me just refresh it. What just happened? Ansh. Don't you dare laugh now. We have to know, like, what just happened. So don't worry, I was in your shoes when I just saw this thing for the first time. So the thing was, I was actually performing some things in my personal project, and I was not aware that Databricks has auto-enabled this feature. I knew like there's something like deletion vectors, but I really didn't turn it on. But it was auto-enabled, and I was like, what? And it took me the whole day to actually understand the root cause, because I didn't relate it with deletion vector. I was thinking like how it can be done. So don't worry, you do not need to spend the whole day. You are here on my channel, you are my data fan, so you will learn everything right now. Okay, so what just happened? Ansh, Lamba, just tell us. Okay. I'm laughing because I am just relating this scenario with mine that actually happened to me on that day. I am still remembering those moments because I was like, what just happened? So, so. First of all, if I just look at the time, this is the first file that was created when we inserted the data. Okay, just take notes. Okay, this was the file. It was created when we created the data and inserted some data. Okay, created the table and inserted some data. Okay, sorted. All good. Okay. Then just forget about this deletion vector for now. Don't worry, I'm just explaining. Okay, so this was created, this is fine, and we were we were I'm also like, I was also expecting, let me just consider myself as you. Okay, I was also expecting only one Parquet file, which will having three records, and obviously the updated record, like three records including the updated one, like 3 and 1 id equals to 30 amount. Okay, and I was expecting just this file, just this file. Okay, because it was the second file, it was created at 2:33:59. Okay, so this was sorted. Why do I have the third file? So the answer is, this is true that this was the first file that has all the records 1 2 3 that we inserted. Then in the previous scenario, without deletion vectors, what was actually happening? It was rewriting all the data, right? It was rewriting all the data. Even if I am just updating one record, okay, it is rewriting the whole data, whole Parquet file. Let's say my Parquet file is of 1 GB. And if I'm just creating one small change, one record, which is hardly of few KB, right? It is rewriting the whole data of GB. Why? Why? I don't want that. I do not want that. Okay, so what deletion vectors are doing? Let me just take you to the documentation now. So now you will see. So, what are deletion vectors? What are deletion vectors? So deletion vectors are storage optimization feature that can be enabled on Delta Lake tables. But bro, you have auto enabled that, so just write this feature now, because I just spent my whole day. So by default, it is talking about without deletion vectors. Now by default, when a single row in a data file is deleted or updated, the entire Parquet file containing the records must be rewritten. We know that. But with deletion vectors, with deletion vectors, now what will happen? It will not rewrite the whole Parquet file. No, it will go inside that Parquet file with the help of deletion vectors. I'm just explaining you with the help of analogy. Okay, so it will just go inside that Parquet file with the help of deletion vector, and it will mark the changed records. Either it is deleted or it is updated. It will mark the existing rows as removed in case of deletion. In case of updates, it will just mark it as updated. Okay, without rewriting the Parquet file. So it will just mark those records, only those records, and subsequent reads on the table resolve current table state by applying deletion noted by deletion vectors, the most recent table version. What does it mean? Let me just show you. So now you know that in this Parquet file, in this Parquet file, it has mentioned what rows are changed. Either it is deleted or updated. Okay, with the help of this deletion vector. Okay, with the help of this deletion vector. Now in this new Parquet file, it will only hold those records which are changed instead of whole Parquet file. Instead of whole Parquet file. Do you want the proof? Do you want the proof? I can just show you. So if I just download this file, let's say if I just download this file, and if I just go on Google, and if I simply type Parquet file viewer, okay, and then I just need to upload my file that I have just recently downloaded. So this is the file. Now we can see, because obviously we cannot preview the data of Parquet file. Otherwise I would have just clicked on edit button, but we cannot preview it because it is encoded. Okay, so this is the data. See, in this new Parquet file, and you can see the Parquet file that I have just uploaded. So this is the Parquet file. So in this new Parquet file, instead of having 3 records, that means all the data, it will just create or rewrite the data which is changed. And how it knows what rows are changed? With the help of deletion vectors. With the help of deletion vectors. See how it optimizes the performance, the cost, everything. So good, so good. And I know now you know what are deletion vectors. Okay, so Ansh, Lamba, everything is done, just one thing is pending. I know, bro. Then what is this third one? What is this third Parquet file? So the so let me just again mark this. So this third Parquet file, it is the combination or collection of both the files. Why? You will know everything about this in the next topic, in the next chapter, which is optimization techniques and how we just optimize it. But for now, I can also give you a hint. So as you know, this file holds 3 records. Yes, this file holds 1 record. Okay, and obviously 1 record is marked as changed with the help of deletion vectors. So that means it will just read 2 records. Okay, 2 plus 1, 3. So instead of reading data from 2 files, Delta Lake combines both the file whenever we just run any DML operation, and it will create one combined file. Why? Because it is always performant to read from fewer files instead of many files. Okay, and don't worry, you will understand each and everything about optimization or merging everything in the next chapter, but I know this will just set a strong base for you for the next chapter. Okay, so now I'm very excited to just show you the delta log, because what exactly happened in the delta log, let me just show you. If I just open delta log, wow, there are like so many transactions already happened. So first of all, as we all know that 00.json will create the data, like create the table. 001.json will insert the data, and I can just open it. I can just click on edit, and I can see it said add CAC partition. Just remember this name, okay? Because we will be just verifying it. CAC. This is the data which was initially inserted and having all the three records. All the three records. Okay, perfect. Then in the second.json, it will say two things. One is, I will show you. Let me just show you. So it will say, first of all, remove the previous partition. Hey, what? Why do we need to remove the partition? Because hold on, hold on. We will first remove that partition. We will say, hey, just take this partition or just take this Parquet file out. Like just remove this Parquet file. Just remove it for now. Just hold on. Just remove it. Okay. Then add the new one. But we have just seen that it contains only the change records. That's correct. That means one record is added. Now we will add back the same partition that we removed for CAC, CAC. But this time, instead of adding all the data, it will say, do not add all the data. Add this Parquet file, we know, but just scroll towards right and just see this one. This time also use the deletion vectors. That means just add this Parquet file, but only read those records which are not marked as changed or updated. Which are not marked as changed or updated. Got it? Got it? Got it? Very good. Very good. Okay. And then in the last one, as I just mentioned, it will just combine both the things. So it will just apply optimize thing, and it will say remove this one, and add this one, which is the aggregated version of both the files. Don't worry, we will just talk about it in the just few minutes, bro. Now you know everything, right? Now you have a strong base of Delta Lake, and trust me, this knowledge is very precious. Just trust me, bro. I don't know how many months to read this, bro. This is the, you can say, condensed version of this whole knowledge. Just trust me. Just respect this knowledge. Just take notes and grow in your career. Get your dream job. That's all what I want. So this is the thing that was all about deletion vectors. This is all about deletion vectors. But before that, we need to cover this topic as well. Versioning and time travel in Delta Lake. Being a developer, you're gonna love this feature, trust me. Trust me. So, what is versioning and time travel? What is this? What is this? So basically, you asked me a question, right? And maybe you would have forgot that question now, but I remember that. So the question was, why do we need to physically keep the files in that folder? If the data is deleted, why do we need to keep the files then? Why? Why? Why do we need to just, why can't we just remove the files? Why we are just putting the removed word in the Delta Lake, like Delta log? Why we are just not removing that file? Okay, let me give you a scenario. Let's say this is your table, okay, and or let's say this is our table in which we have ID. Come on, man, we have ID, right? So we have data such as, wow, it looks so good, right? In the dark theme. Wow, man. I'm just using it for the first time. I always prefer white. Okay. I do love black, as you can see. Most of the time we are black, but so this was our ID. Okay, and then 2 was ID, 3 was ID, then some data, some data, some data, some data, some data, some data. Then if you remember, we deleted this record, right? So in the table, we do not have this data. And you are saying that why can't we just physically delete the Parquet files? Why? So let's consider the scenario. where we had like two Parquet files. I'm just talking about without deletion vector because it is always easy to understand without deletion vectors because you do not need to worry about the additional Parquet files it creates. So without deletion vectors, it kept your this partition and in which they have like records 1, 2, 3. Then it created the new partition, this one, in which it removed that particular record, which is id equals to 1. But after some time, you realize that you were not supposed to delete that record. How can you just bring back that record now? With the help of time travel, bro. With the help of time travel, you can just use time travel in order to get back the data. Really, let me just show you how you can do it. So we will simply go to our Delta Lake. Okay, and this time let's use our without deletion vectors notebook because it will be easier to understand. It is like same because obviously we do not need to worry about managing those delta log. Delta Lake is automatically creating that. Okay, so let's say you deleted this record, right? So if I just query now, let me just put the heading such as should we just create a new one? Oh, no, it's fine. Okay, so we can simply say put a heading first. Okay, sir, and then we can say time travel and versioning. Okay, so let me just query the table how it looks like right now. Select asterisk from delta catalog dot raw dot dml. Let me just query it. Obviously it does not have that record id equals to 1, but your manager is shouting at you, what you have done, what you have done, why you deleted that record, why? So then you can say take a chill pill, have some shake, and I will just get that data back again. How? Because we have watched Ansh Lamba's video. Just kidding. So now I will just simply run a command describe history, and obviously I need to pick SQL. Okay, describe history and then table name. Table name is delta catalog dot raw dot perfect. Now it will show me all the versions of my table. Wow, this is just wow. I will see all the versions of my table. So as you can see in the version 0, this is version 0. Okay, in the version 0 it created my table. If I just scroll it down, it says operation is create table. In version 1 it writes the data. Obviously we wrote the data. In version 2 it updated the table to remove the deletion vector. Then we updated the table, we updated the amount, right? Then we deleted the record. Okay, if so these are all the versions. If I want to time travel to any particular version, so let's say I want to go back to version 3, okay, where we have data which is updated and no deletion happened. How I can just do that? It is very simple. So for that you can use a command for time travel which is called restore. Okay, so I'll simply say restore Ansh Lamba pick SQL. Okay, restore table name delta catalog dot raw dot this. We do not need your suggestion, we know what to write. Okay, so this is the restore command. Now we need to say which version we need to pick as our destination, like to which version we need to go. So I will say to version as of 3. Let me just run this command. Let me just run this. Quick, we need to show the results to our manager. Just kidding. Just kidding. Okay, done. Do you really want to query the table again to show it to your manager? You can simply type select asterisk from delta catalog dot raw dot dml. and your manager will be so happy. We got the record back. We got the record back. Wow. We got the record back. So this is these like I love this feature a lot. Like being a developer, like we can make some mistakes in the development environment, I know, but it is very important to actually have these things. So what it did, so it just mentions this information in the delta log that go back to that particular version. Simple. It has like JSON files, right? So it is just referring that particular version. That's it. 003.json. Simple. It is not referring that 004.json now. Simple. Time travel. So now that doesn't mean that you can just crazily like delete all the records. No, no, be in limit. Okay. But this is your savior. Okay. So now, Ansh Lamba. What if we forcefully, like we intentionally want to remove the data? How you can do that? It is very simple. Just go to your let's say table. Let's say this is your table. Let's say this is your table, and just delete the partition. Don't you dare do that. Don't you dare do that. It will just mess. It will just create a mess. It will be a mess. You will not be able to query your data. Why? Because because table will go there, like query will go there in the delta log, okay, and then it will search for that particular partition, and you has like you have like let's say removed this partition. Delta log is saying, what? I cannot see that partition. I cannot return the results. Now I cannot do anything because you deleted that. So to not do that, I was just kidding. Okay. So Anshlaba, how we can do that then? How we can just do that? Okay. So let's say this is my table. Let me just put my table back to that particular version. Let's say I want to just go back to that version 4. Okay. Let's say version 4, and it will take some time. No worries. Mm-mm-mm. Quick, baby, quick. Done. Okay. Then if I just query this table, it will show me the latest result. Now, what let me just take you to the folder. Now, what I know that only one partition is being used right now by my table, which is this one, the latest one. And this is the table without deletion vector. Okay. So this is the table, and this is like same scenario with deletion vector as well. But it is always easy to understand without deletion vectors because you do not need to get confused with so many Parquet files. Okay, so that's why I'm just referring that concept without deletion vector. It is easier for you to understand. And once you understand the concept, then you can just simply go to your deletion vector and you can just understand it. Okay, it's always about how easily you can just grab the concept. Concept is everything. Concept is everything. Then people build products, services, everything on the basis of concept. Okay, so we know that only this particular partition is being used by my table. I do not want to use these partitions at all. I want to remove these partitions because I do not want to just pay for the storage that I do not want to use. Okay, do we have a solution for this? One solution I just mentioned that, but do not try this. Try it at your own risk. Okay, so do not try that particular method. I will just show you the best method that you can use to remove the partitions. What's that? Let me just show you. It's called vacuum. Vacuum command. Vacuum command in Delta Lake. So what it will do? So as we know that this is the partition that we are concerned of. So when we say vacuum and then we just put the table name, it will remove these two partitions which are not used by my table, but there is a default time frame that it does not delete this. So the thing is, let's say these are the two partitions, okay, and these are not being used by your table, but these two partitions are just created. If your partitions equivalent to Parquet files, I already told you. If your Parquet files or if your partitions are not older than 7 days, it will not remove those partitions or Parquet files. Obviously, you can configure this using table properties command. You can just change this time frame, not a big deal, but by default your data, your information, your Parquet files will be there for at least 7 days. But you can just use additional command which will just remove those partitions. I will just show you, don't worry. So you can actually see like this data will be deleted. And there's one more command along with vacuum. It is called dry run. So let's say dry run. Let's say you want to see which partitions will be deleted before actually deleting those partitions. Obviously, because in the real world you will be have like thousands of Parquet files, right? Like let's say at least hundreds of Parquet files, right? So you can just run this command dry run in along with vacuum command, and you can see what are the Parquet files which will be removed if you run this vacuum command. Okay. So now let me just show you how you can just use this vacuum command. Let me just show you. So let's go back to our Databricks workspace and let's cover this vacuum command %md, and let me say vacuum. Okay. So first of all, I will simply run the vacuum command using dry run, because before actually removing those Parquet files, I will show you how it will look like. Okay. So I'll simply say vacuum equal vacuum table name delta catalog this. Oh, just do not give us the spoilers. Okay. So basically we will simply write vacuum. Okay. And as I told you that it will not delete any file physically if they are not older than 7 days, but we can still delete those files if we do not want to keep them. And for that the statement is retain and then hours that we want. So I will simply say retain 0 hours. Okay. So what it will do, it will just remove those files and it will not check the condition for like 7 days, and for that we need to just turn it off as well. I used to turn it off till I think last week. I don't know if it is updated or not, because this is a world of surprises. Okay. So before actually doing it, I will simply say dry run. Okay, let me just run this and let me see what happens. Yes, we need to turn it off because it is saying, are you sure you want to just remove this with such a low blah blah? Yes, bro. So you can just go to the documentation and you can just set that property, or you can just simply click on diagnose error. It will just give you that code to just remove that check flag. We need to just click on false. See, spark.databricks. So we can simply set this setting to false and then we can simply do this. Okay, I can just add this here and then I can just run this. Perfect. By the way, we are not physically deleting the files, we are just running it. We are just seeing like how many files will be deleted, because it is a dry run. It is just a dry run. So perfect. So now as you can see that you got all the partitions, in our case it is just 2, all the partitions which will be deleted. So it is saying, hey bro, you are just running vacuum command, so these partitions will be deleted. Okay, we will say yes, okay, and just remove these partitions. Not do it, do not do it in production or anywhere else. This is just like, so now you will say like, why do we need to remove those partitions? So there are some policies such as GDPR where customers have the right to ask any company to remove their records from their databases. So in that scenario we have to physically remove those records. So in that particular scenario we can use vacuum command. That's another uh, interview question, because they can ask you like, why do you not need to remove the data? Why you need to actually use the vacuum command, or what is the possible scenarios where you need to tackle it. Okay, so it is removed. I am very excited to see what exactly happened here. Let me just refresh it. Boom, all those two partitions are gone. All those two partitions are gone. Bye bye, tada, bye bye. Simple. This is the vacuum command. See, now let's talk about the optimization technique or optimization, how we can just tune the performance and everything. And we will be covering optimize command, zorder by together, and then we will just take liquid clustering. Okay, let's see what's that. Let's see. So let's talk about the optimize command in Delta Lake. So there are basically three commands: optimize, zorder by, and liquid clustering. Let's talk about optimize first. And by the way, optimize and zorder by are like interlinked. So let's talk about optimize first. So basically, let's say you have three Parquet files. Okay, one, or let's say you have four Parquet files. It will be easier to explain. So 1, 2, 3, 4. Okay, and in each Parquet file you have just two records. For now, you can just take it for like example, right? So you have just two records in each one, like 1, 3, 5, 4. Okay, then let's say 1, 2, 3, 5, 2, 6. I'm just counting. Then 8 and 7. Okay, id 1, 3, 5, 4, 2, 6, 8, 7. Okay, then this is like all this data is stored in the like one folder, right? Now if I am querying this data, let's say this is you. Okay, if you query this data, so now Databricks or our cluster will read all these four partitions, right? And let's say this is of 1 MB each. Let's say 1 MB each. Okay, now it needs to read all those four partitions, right? It needs to read all those four partitions. Now according to the rule, it is always easier to read less partitions. That means bigger in size, big in size, because obviously if you just have like less partitions, it will be like bigger in size, right? Then just make notes, bro, like this. See, my drawing is so good. So then more partitions which are smaller in size, obviously. So this is a rule. This is a thumb rule. Okay, okay. This is the rule of thumb. This is the rule of thumb. So what if I what if I combine, like I coalesce, the right word is coalesce. I just coalesce these partitions, like four partitions into two. Let's say this one like this, one, and these two partitions like this is, and these two partitions like this. Will it will be easier to read according to the definition? Yes, yes. So data here will be 1, 3, 5, 4, 2, 6, 8, and 7. So this is the back, like behind the scenes working for optimize command. So it will coalesce your partitions. It will coalesce your partitions. How it will just pick the size, it will be decided by Databricks. So what will be the optimal size for like partitions? So it will just create one. In the real world, if you have like 4 files of 1 MB each, it will only create one file. That makes sense, right? So but for the example, we have taken 2 files. Okay, so it will just coalesce these two partitions. This is the optimize command. This is the optimize command. Yes, this is the optimize command. So now before actually implementing it, I will also show you the zorder by command because it is interrelated to optimize command. So for that, let me just show you. So when we talk about zorder by, so this is the same scenario, right? This is the same scenario. And in the recent scenario, we just coalesce these partitions. What if I tell you that when you create these two big partitions, you can also sort this data. What do I mean? I can simply say 1, 2, 3, 4, 5, 6, 7, and 8. Instead of creating 4 partitions, you can create 2 partitions, big partitions, and sort that data. That is called Z order by. What is the benefit of it? Benefit is called data skipping. Again, another interview questions question. Data skipping. So let's say I run the query. I run the query as, let's say I say select asterisk from table where id uh, equals, let's say, 3. Okay. So if I do not sort this data, if I do not sort this data in that scenario, if you remember the previous 2 partitions, it was like randomly distributed. So query needs to check this partition as well, and this partition as well, because it does not know the min value and max value of this partition. Min value and max value of this partition, the column statistics. So all these information will be stored when we enable Z order by, like min value of like ID column, max value of ID column. But when we applied Z order by, we can leverage data skipping. What do I mean? When I use this query, select asterisk from table where ID equals to 3, query will go here in this partition first. Okay. It knows the min value of this partition is 1, the max value is 4, and id is saying that it needs to fetch the data for id equals to 3. That means all the data for id 3 will be in this partition. Make sense? Common sense. So it will not read this packet file. It's called data skipping. It will skip this partition. It will skip this partition because it knows the min and max value for all the partition, plus it knows like data is like sorted based on that data. Simple, simple. So now we can see like how we can actually implement this. It is very simple. So let me just go back to our workspace. Perfect. And in order to apply those things, so first of all, I will just write more data so that we can have more partitions, because we have just removed other 2 partitions. So let me just write more data inside this. I will simply go at the top and I will simply say write more data. Let me just run this command for 2 to 3 times. Like, 1 time is done. Okay. And 1 partition is already there. So now we have 2 partitions. Let me just run it for 1 more time. 3 partitions. Okay. Let me just run it for 1 more time. So now we have like 4 partitions. Okay. Perfect. Let me just check. Let me just refresh it. 4 partitions. Perfect. Now I will simply say Z order by and that optimize command. So I will simply say %md and I will say Z order by and optimize. Perfect. Or let's say first optimize command, because Z order by makes sense. Like we can just again do the same steps, or yeah, let's cover it differently. Yeah, let's cover it like this. Okay. So first of all, what I will do, I will simply say optimize and my table name, which is delta catalog dot raw dot table. What was the table name? No, table name was ext. Now it is not giving a suggestion. Why, bro? Okay, because we have not picked SQL. That's why. Because it is very famous to give spoilers. Okay, so now I will just run this command. What it will do, according to the concept that we have just discussed. So the answer is, it will just combine all those 4 partitions into a new one, because all those 4 partitions are very small in size, so it can just be fit in 1 partition. So let me just refresh. New partition is created, as we all know, and the new partition is this one. And all these 4 partitions are tombstone because we do not need them. Perfect. This is optimize command. It just combined all the partitions. See, now we do not need to do much with the implementation. Everything is becoming automated, but the concept, the logic, the architecture behind those powerful statements is so complex right now, and it's very hard to find because everyone concerns about how we need to implement it. But let me just tell you, bro, now our data engineering community, or let's say data engineering domain, is tilted towards more into concepts, fundamentals, architecture again, and not much into implementation, because implementation is so easy right now with the tools such as Databricks, Azure, like all these cloud tools, right? Obviously concepts, fundamentals were important earlier as well, but earlier we were more focused towards implementation because there was no like written rules like how we need to just implement this solution. We were just trying and we were just testing it, so we were just devoting more time into implementing such solutions. But now we do not need to worry about implementation, we need to worry about how things are actually happening behind the scenes, right? And that's why these things are really important. And you know the spot, you know the right location from where you need to get that all that information, okay, all that knowledge. So this was all about optimize. Let me just add z order by as well along with this. So z order by, and I can just pick column such as id. Okay, let me just run this command. So what it will do, obviously it will just create one partition which is already there, and it will just sort that data for that partition. So let me just refresh it. See, so obviously this is the partition and it has just sorted the data inside this, and now whenever we will be querying the data, it will just go and just check the min max value and it will just fetch the partition. Obviously it is just one partition right now, but in the real world we will be having hundreds of partitions, and we can just skip the partitions using z order by command. Okay, sorted scenes, sorted scenes. Now there's a new concept where we do not need to worry about partitions. It's called liquid clustering, and this is the most recent addition to tune the performance. It's called liquid clustering. So what it will do, let me just show you. So let's talk about the liquid clustering. So let's say you have these partitions, like you had these partitions, okay? Now you do not need to worry about partitions, and it says like do not ever create the partitions because it can create the problem of like small file problems. They are like some optimization techniques, but still it is very hard to handle the partitions. So we have something called as liquid clustering. So what it does, it creates the clusters. Wow, like we can define the column on which column we need to create clusters, and clusters are obviously based on the similar values. Let's say it create cluster for like value similar to like 1 2 3 4 5 6 7 8 9 10, and then another cluster of like value similar to like 1000 1001 1002 1003, and then another cluster. And these clusters are dynamic clusters. These clusters are dynamic clusters, and it will be changed according to the query behavior. So let's say we are just querying using, let's say, a condition, let's say select asterisk from something where id equals to 100 and amount equals to this, product id equals to this. So it will create those clusters as well, which are oftenly used by the users, which are in use very often as compared to other values. So it will just create the clusters for that as well, so that it can just instantly return the results for that, and it knows like how to just aggregate the data. So we do not need to worry about partitions. It will create dynamic clusters. It will create dynamic clusters. Yeah. So earlier, if we want to enable liquid clustering, we had to like create a new table, because we were not supposed to enable liquid clustering on top of any table. But now it has given us the opportunity to just alter the table and just create or just update the table which is already created, and you can just turn on the liquid clustering. And let me show you how you can just do it. So simply go to your Databricks workspace, and let's say if you want to just create a new table, and let's say create table and table name delta catalog dot raw dot liquid table, let's say. Okay, then I will simply say id int, and then amount, let's say double. Okay, then let's say name string, Okay, simple. And then I can simply say using delta, which is completely optional, and location abfss raw at the rate storage delta lake Ansh dot dfs dot core dot windows dot net. Perfect. And let's say I want to create liquid table, liquid table, liquid table. Perfect. And then I can simply say cluster by command. Okay, and then I can just put the column. Let's say I want to create cluster based on ID. I can simply run this command. So now if I will be just writing, oops, what's wrong? URI schemes, what just happened? Oh, we need to just put abfss. We just put abfs. Simply run this again, and then it's done. So now if we are just putting data or inserting the data using any data frame or anything, it will not be creating any partitions because it is not recommended now because we have enabled the liquid clustering. So it will just handle all the dynamic cluster on its own, and there's no need to just put partition by this column and all. Nothing. It will be handled by Databricks. Sorted. So it was about liquid clustering. It is very new. You can just explore this and obviously try to use this feature. And I was just reading the documentation. It is, I think, 50 to 60% faster than the ZORDER by an optimized command. So it is much faster than ZORDER by an optimized command. Just imagine how fast it is without ZORDER by an optimized command. So it is very, very, very powerful. That's why I love Databricks, right? Like they are just putting so much of efforts to make the data engineering world performant, and obviously they are upgrading so quick. So this was all about liquid clustering. So now it's time to talk about schema handling in Databricks and obviously in Delta Lake. Let's see what is schema enforcement. So schema enforcement is basically very helpful. Okay, I will tell you, don't worry. So let's say this is our source, okay, and this has the schema as ID, amount, and product ID. Okay, and we created a sink. Sink means destination. Okay, destination. Okay. Oh, I just removed it. So sorry. So this is our source. Okay, and this is, these are the columns. Okay, and this is ID, amount, and product ID. Perfect. Then we have destination. Perfect. And destination, obviously when we just put this data here, it will have the same schema, right? So it will just keep this data. Okay, ID, amount, and product ID. So it will save this schema as the, like, this is the fixed schema. This will be fixed in Delta Log. Okay, now the best quality of Delta Lake is, it is schema on write. So it will always check the schema whenever it will be writing the data. Whereas in Data Lake or in any other format, it is schema on read. It will just write the data without matching any schema, and then it will just throw the errors if schema is not matching with the other files. Yes, bro, yes. So this is schema on write. So now this schema is fixed. Okay, now let's say in the source next day, or let's say in the next iteration, we got another column called customer ID, and now it is trying to ingest the data. Delta Lake will say get lost. Why? Because you are not following the schema. Schema has just ID column, amount column, and product ID column. That's it. From where did you get that fourth column? It will say, bro, actually we just got the data, and please allow us, and can you please allow this column, please. So Delta Lake will say, According to schema enforcement, the answer is no. But, but with this schema evolution, it is possible. So how we can evolve our schema? So basically, what we will do, we will simply say it is called merge schema. So we will use this function and we will merge this schema into this destination, and we will say, okay, I will allow you this time, and then this schema will be fixed. This schema will be fixed. If source changes the schema for one more time, then again we need to use merge schema. So you can evolve the schema. So first of all, let's see how you can just evolve the schema using merge schema command. Let's see. So for that, let's quickly create a new notebook. Okay, let's go to this workspace and then create new notebook, and then let's call it as like 4 delta lake. Perfect. And then just connect your cluster with this notebook, and let me just say %md, and I will say schema evolution versus, or just schema evolution. Okay, let me just say %md, and let me say merge schema. Okay, perfect. So for that, what we will doing, we will create a data frame. And how you can just create a data frame? Again. If you want to learn everything in the world of Pyspark, you can definitely watch my Pyspark tutorial video. It is 6 hours long, full course for Pyspark, in which you will know each and everything. Each and everything means each and everything, and that will help you to become a pro Pyspark developer. So we will be using Pyspark in few chapters now, and you can definitely see that. If you do not know how to work with that, you should definitely watch that video. So do not need to wait, just click on the video coming on the screen, just click on the I button and just start learning Pyspark right away. And if you think that you can just continue doing that after this video, then do not forget to do that. Okay, let's do this. So in order to create the data frame, we will simply first create my data. Okay, and we can simply put data inside that. Let's say 1, and then let's say I'm just putting product as like category as like food, let's say, and then I need to just pick the amount, and amount will be $10. Then similarly I can just create more. Okay, it has created some for us. Okay, perfect. This is my data just for now, and I can just also put my schema. Okay, and my schema will be id of int type, and then category string, and quantity int. Quantity, no, price, or just amount, let's say. Okay, perfect. So this is done. So let me just create a data frame out of it. So df equals spark dot create data frame, and I will simply say my data and my schema. Perfect. Oh, I have used J in my schema. Let me use H. Okay, let me just run this to create the data frame using this demo data. Okay, so now I will say df dot display to actually display the data. Perfect. Perfect means perfect. So this is my data frame. Now I want to just write this data to a location. Okay, so I will simply say df dot write. So again, I'm saying if you need to just learn Pyspark in detail, you can definitely watch my video. Okay, so df, then I will say format, and format will be delta. Okay, then to go to the next line, you just use slash. Mode will be override. No, we need to just use mode as append. Again, all these modes are also discussed in that video. That is a great video. Oh, I just clicked, just hit shift plus enter by mistake. Okay, then we need to just give the option part, because we need to define the path. So it will be abfss, and inside the raw container, storage delta lake ansh dot dfs dot core .windows.net, and within this I will just create, let's say, uh, schema table, let's say. Okay, schema table, and then we just need to say dot save. Perfect. Let me just run this command and it will just write the data using Pyspark, and we will have the data. I can just validate this as well. So I can simply go here and inside raw I have this table. Okay, this is the delta log table that I have. It has created 4 partitions because my cluster having like 4 cores, so that's why. Okay, so now this is done. This is done. Now if I just try to put more data, okay, let's put more data. Let's say my df, this one, let me just create one more cell and I will say df equals to, like, I just need to insert more data. Okay, so it has just defined, like, wow man, thank you so much. So now I have like df new, I can just say df new. Okay, and then I will simply apply the union because I have added new record 5 food 50. Okay, I will simply say display. Perfect. So now one row is added. Okay, now I will just insert this data inside this using df new. Okay, let me just run this. Will it allow? Obviously, because both having the same schema, right? Now everything is fine, everything is fine, everything is fine. Now what I will do, I will break this schema. I will break this schema. How I will break the schema? So I will simply add one more cell here and I will create one more column. And in order to create new column, I will simply say df underscore new dot with column, which is a function used to create a new column. And I will simply say flag. I want to create a flag column and I want to give the value as lit1, which is used to define the give the constant. And for that we need to import the library as well. So I will simply say from Pyspark dot SQL dot functions import asterisk. Perfect. So now red mark is gone. Perfect. Now I will just show you the data. Now I will show you the data. So now we have like one more column. What will happen? I will simply try to write this and it will give me error. And I want this error now. Why? Because in the real world, let's say your pipelines are expecting the exact schema. Then what you will do? Your whole data warehouse can be broken, right? So schema enforcement is really, really helpful. But in some scenarios, you need to allow the new schema. So for that, as we just discussed, I will just use a function called merge schema. I will simply go here, hit enter. I will say dot option, then merge schema will be true. Perfect. Perfect. So this is the statement that I need to use. Let me just zoom it for you. See, merge schema equals true. Now I will just rerun this and it should run fine. It should run fine. Perfect. 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 Do you want to see the data? Let me just show you. So I will simply say df equals to spark.read.format, because now we are reading the data. So delta dot load, and what is the location? Location is this one. Let me just say df dot display. Now you will see that column is added, and obviously for the previous record it will show null because that was not there before, but for new records it is there, and for previous ones it will throw null. That's common sense, like it was not there before. See, that's how you can handle new schema. You can evolve schema. How was it? How was it? So after this, let's talk about one more powerful feature, and it is, so we have something called explicit schema updates. What does it mean? So when we are just playing with schema, but we are not actually imposing that schema to the Parquet files, those schemas will be handled at the delta log level. Those schema will not be passed on to the files. So such as if I want to just add a column to my table, if I want to add a column after a particular column, if I want to reorder my columns, if I want to rename my columns, so all these changes will be done at the metadata, at the delta log level. These will not be imposed to the files. We can impose these updates to the file level as well, but for that we need to run a special function for it. It's called reorg. We will discuss it about reorg as well, but after this. Okay, let's quickly see explicit schema updates in Delta Lake. Let's quickly see. So if I just go to, oops, behind the scenes. Okay, so if I just go here and if I just say here percentage MD and I will say explicit schema updates. Okay, explicit schema update. So first of all, I will cover add a column. Perfect. Let's quickly add a column. And what table should we pick? Actually, we can pick the table that we created in the third one. Like if I just click on catalog, I can just pick any table. So in raw schema, we have, let's pick external table DML because we are familiar with these operations that we are applying. So let's pick this one, external table DML. So if I just pick, if I, let's say I want to alter this table, alter table, and table name is delta catalog dot raw dot external table DML. Okay, and I want to add a column. Add column, new column will be flag of type string. Simple. Let's run this. So what will happen? So I can just query this. I can simply say select asterisk from this table. Perfect. Let me just query this. So it will just give me a new column, obviously, and obviously the values are null because we haven't specified any values. So now if you just check the delta log, let me just go here and let me just go to DML table. So if you observe it carefully, that we just have 5 partitions, right? And there's no recent partition it has created. It's like last partition was at 334 and now it's 420. Why? Because the schema was not changed in the files. If I just download this Parquet file and if I just upload this Parquet file in Parquet viewer online, I will not see the new column. No. Then where is that new column? The new column is here in delta log. I can see this particular, oh man. Okay, so these are like checkpoints that I was talking about earlier, right? So just see the new JSON. Click on this one, 13 JSON. Okay, perfect. Then click on this edit button. Then you will see in the metadata, you will find that column. Let me just search for it. It's called flag. Where is it? See, flag of type string. But it is not in the file. It is not in the Parquet file. No, it is just at the metadata level. Very good. One feature is done. Now, what's the next one? If I want to add a column, let's say I want to add another column, and let me just give a heading, and I will say add a column after. If I am very specific that I want to add a column after, let's say ID. Okay, so I will simply say add column, and I want to say this column name as new call. Let's say new call, and after ID. Now I will just run this. Then I can just query this table, select asterisk from this table. Then it will create the column right after that ID column. See, right after that ID column. But again, if you just go here, if you just go to your raw container, your folder, no partition is recreated because again the changes are at the metadata level, at the delta log level. Because we are not applying DML command. These are not DML command. These are DDL commands, alter table, right? Then what is the third one? Reordering columns. Okay, this is special. Really? Let me just show you. because for this we need to turn on one particular function, only then we can perform this. But I want to write this and I want you to see the error it throws. Okay, so percentage md, and then I can say, oh man, I'm really hungry. Reordering columns. Okay, so I can simply say alter table, and table name is dml, and then I will say alter column, and column I want to alter as new column. Okay, so I will say new column, and I will say after flag, because I want to just put this column after flag. I just changed my mind, so I will simply say after and then flag. Perfect. Let me just run this. It won't allow me to run it. I think so. Oh, okay, it's done. I think it is with the renaming of columns. Okay, so now if I just again query the table, select asterisk from, so if I just run this table now, I should see, yes, I should see the column is moved after flag. So what about if I just want to rename the column? If I just want to rename this column from new call to, let's say, new flag. Okay, let's say. So I will simply say, first of all, percentage md and rename columns. Okay, so I will simply say alter table, and table name is this one, and I will say rename column new call to new flag. Okay, let me just run this. Let me just run this. Column rename is not supported. Yes, yes. I was talking about this error. So I was just talking about this particular error, and it is about mapping. And to actually solve this error, we need to just put the reader version equals to 2 and writer version equals to 5, and then only, like, basically we're just enabling the column mapping, right? So we have the code to alter the table, or simply just click on diagnose error to actually get the code. Otherwise, we have to go to the documentation to get that code. So it will just give us the code. Don't worry, do not need to go anywhere else. See, I just need this table, this information. Oh, this one, alter table, this one, and set table properties, this one. Okay, thank you so much. Thank you so much. So I will simply run this code first. So I am actually enabling column mapping mode by name, so I can just map the column. Because why it is needed? Because column needs to be mapped, right? We are not making changes in the Parquet files, we are making changes in the delta log. So that's why. And minimum version, reader version is 2, writer version is 5, as I just mentioned. So I will first run this. Okay, so it will just take few seconds, and then I can just run this command, and then you will see our columns are renamed. Not columns, we just have like one column that we are renaming. Oops, I just need this table name. I just copied the whole thing. Perfect. Perfect. Let me just run this. So you will see my column is renamed. Yes, and all of these things are done without even touching the Parquet files. Everything is done in the delta log. Everything is done in the delta log. See, everything is done in the delta log. So now, what's next? As I just mentioned that, let's go back to the presentation. As I just mentioned that, if we want to impose those changes in our Parquet files as well, so that everything is aligned, right? Because let's say I'm just checking my data, I'm just validating something, I will see, hey, columns are different and it is different delta log. So we have a command called, it's called reorg. Okay, so this reorg command will impose the changes to the Parquet file. So when I just run reorg command, you will see all the changes will be applied or aligned with the Parquet file. Let me just show you. So I will simply say reorg command. I'm just showing you so you can just also try it on your tables. So simply you just need to type reorg, first pick SQL. Okay, reorg, and then just table, and table name will be delta m, and then you can just say apply purge. So purge will basically remove the unwanted data. Okay, so if you have like some tombstone file, so it will be just removed. So let me just run it, and it should be done in just few seconds. Perfect. So this was all about reorg command as well. So now finally it's time to actually look at the structured streaming available in Delta Lake. And do not afraid of the word streaming. It is very simple with the help of Delta Lake, because everything is automated. And let me show you how things will be working with Delta Lake and structured streaming. So let's talk about structured streaming. What actually is structured streaming or data streaming? It is very simple. It is called continuous flow of data. What do I mean? So obviously we're gonna cover structured streaming with delta tables, and with delta tables you can say it is so easy. Delta Lake has made structured streaming so easy, and you will just get to know when you will be actually applying all those learnings or concepts that we are discussing right now. So let's say this is your source. Okay, this is your source, and this is a delta table. Okay, and this is your first entry, or let's say first iteration of data that appeared in this particular source. Then you created a destination. Okay, perfect. So now the thing is, you inserted this data here. Okay, then after some time, let's say after 5 minutes, another stream of data came in this table. But now instead of manually running this flow, you need to create a stream so that it will be automatically be going here. Okay, so it will be automatically going here as soon as data arrives here. Simple and sorted. So let's say my second iteration of data came here. I want my data pipeline to be triggered automatically, or let's say the flow triggered automatically. Then let's say after an hour it appeared here, the third file, or let's say third iteration of data, I want this data to be here. So this is a kind of structured streaming. So now you will say, hey Ansh Lamba, we have few questions. Obviously you should have, because I also had some questions when I was learning this. So how it is only picking this particular file, that means new file every time? How? So let's say this is third file. How it just picked this third file, and how it didn't pick these two files? Why? So when we write the data in destination, we create a folder called, or let's say a kind of location, it's called checkpoint. So it is a checkpoint location that it uses to refer this information. So let's say this is your first stream. Okay, it writes the data here. It will write this information in this checkpoint location, and then if next data comes, when it will be reading this data, it will go to the checkpoint location first to read the current state of the stream. Okay, to read the current state of the query, the whole query, and it will say, hey, this file or this partition or this version of table is already there, you just need to pick this file, the new one. Then it will just pick the new one, and it will save that information in this checkpoint location. Same with third one, same with all the future files, all the future files. This is the architecture behind streaming, structured streaming, structured streaming, structured streaming, structured streaming. It was a chaos when people were managing this checkpoint box, but all thanks to Delta Lake, it has automated everything, and it is taking care of all the states, all the versions, all the previous states of the data, tables, everything. And we just need to create this checkpoint location. That's it. That's it. So simple, right? So let's create a stream. Okay, let's create a stream. So I will simply go to my Delta Lake, and let's create a new notebook. Go to workspace, and simply click on new notebook. Okay, and we will call it as 5 Delta Lake. Perfect. I will connect this notebook to my cluster. Okay, and let me just remove all those other tabs. Okay, perfect. So now let's create a new table for streaming, and we will call it as source, and then we will create, like, this will be our landing table, like the source, the real source, right? Right. So let's create a table. Okay, and this will be our source. Let me just write it for you. So let's say source table, source delta table, because we are covering structured streaming with delta tables. So this is our source. So I will quickly go to my recent notebook, like maybe to Delta Lake 2, to just get the code to create the table. Okay, and then I can open my current one, the 5. Okay, so let me just paste it here, and I will call it as stream source. Okay, I will call it as stream source. So let's create this table. Perfect, and let me just insert some data as well. Then I can just close this, and this is the command. I will say stream source, obviously. So now it is being created, so I need to just wait for a few seconds. So it is done. Yeah, perfect. Stream source, stream source, stream source. Perfect. Perfect. Now I can just insert some data. Okay. So it will just push some data. Okay, into this table. It's done. Okay, perfect. Now we just need to use this table, which is called stream source. Okay, and then we will create a streaming table, and I will call it as, let's say, stream sync means destination. Okay, so this is stream sync, and this will be my streaming table. This will be my streaming table. Perfect. The stream sync will be my streaming table. So what it will do, this will receive the records as normal, like as usual, as like any normal table receives. Okay, then I will just run this query, the streaming query, on top of this, and then I will just push this records as soon as any records or any new data arrives here. Simple. So let's do that. Now we have this data. Okay, so now I will just create a streaming query. So I can simply say streaming query. Oops. Oh man. Streaming query. Perfect. So now I just need to put the streaming query and how my query will look like. So simple, df equals spark dot read, and this time I will pick read stream instead of just read. I will pick read stream. Perfect. Read stream dot table, and my table will be delta catalog dot raw dot it's called stream source. Perfect. Stream source. Okay, now let's just run this command. So what will happen? What will happen? One error. And what's the error? Oh, we just gave wrong table name. So we just put underscore here and there's no underscore. Okay, no worries, we can just read on it. What will happen? Nothing will happen. Why? Because of lazy evaluation in Spark. So this will only be executed when we hit the action. So this is a kind of fundamental in the world of Pyspark. No need to worry. So In order to see the data, we have two options. I can either say df.display and I can see the data, or I can directly write this data into the stream. That's what we always do. So here's the tip. I will just show you. Don't worry. Whenever we start the stream, it's our responsibility to pause it, to stop it. Otherwise, like cluster will be running, right? So we will simply say df.write stream because we are just writing stream. Okay. Let me just, yeah, it is fine. Okay. So then I will say dot format, in which format I need to write, obviously delta. Okay. Then I will go to the next line and then I will say dot option, and as you can see, it is just suggesting, it is saying what will be the checkpoint location. As I just told you that we need to just put the location where we need to save the checkpoint for the query, and everything will be managed by Delta Lake. So thank you so much, because just ask anyone who is like experienced for like who was just managing streaming before Delta Lake, so they need to just manage so much, but now it is all automated. So checkpoint location, I just need to define the location, and I will just pick abfss. Okay, and I can say let's say raw container, obviously storage delta lake ansh dot dfs dot core dot windows dot net. Okay, and within this I will create one folder called stream output, let's say. Okay, stream output, and or stream sync, because we decided we will just pick stream sync. Within this I will just create a folder called checkpoint. Perfect. So this will be the location for checkpoint. Okay, perfect. Then I just need to define the trigger. So how often I need to just trigger this write stream. So let's say data here is coming in just like 5 seconds, in every 5 seconds. Okay, so I can just run my query in like process the time for like 10 seconds or just like 5 seconds. So I will simply pick processing time equals 10 seconds. So it will just go here, like it will just read this data after every 10 seconds, and if data is there, it will just pick the data. If data is not there, nothing will be happening. Okay, then we just need to give dot start. Dot start means we are starting our query. So I can simply hit tab, but I need to change the folder name, and I want to say data, because I will create data folder within my stream sync. Okay, let me just run this. So as you can see, stream initializing. So now stream is initializing. Now actually streaming query is triggered. Yes, so now I will just show you the graphs as well. It is like very beautiful. If I just click on this, you will see two graphs where you will see all the processing rates, like graphs and all. Like you will see like data is coming, because we know that we have some data there, right? We have some data in the source, so it will just pull that data, and you will see the fluctuation in this graph because it is real time. See, I didn't do anything. So now it has just pulled the data, I guess. Yes, and it is still running, because it will be running, and it will be checking the source after like after 10 seconds. Okay, so now I have the data. If you want to confirm, I can just show you. So if you just go to the raw container, and if I just show you stream sync, and within this I have data. See, I have the data. Now we're gonna test it. How? Let me just show you. Let me first query the data. Select asterisk from, and we do not have any table built on this data, so we'll simply say delta dot text, and I can just simply copy this location to just display you the data, and I will show you that no data duplication will be here because of the process called idempotent, which means like it will, like there's a keyword for that. It's called exactly once. Yep. So this can also be asked in your interviews, like what do you mean by exactly once, and what is the importance of exactly once in the Delta Lake, or in like anything, like if you are just streaming the data, if you are just loading data in batches as well, it is really important. So the thing is, as you can see, that this data was last updated 10 seconds ago, so it will be rerunning everything like every after 10 seconds. Okay, so as you can see, now it was updated 10 seconds ago again. So it means it is following the rule of idempotent. That means data is there in the source, yes, but that data will be pulled only once, only once. That's why we call it as exactly once. Even if our streaming query is running, still that data will be pulled exactly once. That's it. So just remember this thing. So I'm going to show you this data, how it looks like. So obviously we have like 3 to 4 records, 3 records. Okay. Now let's insert 3 more records, the same records, right? Let's change the value. I will simply say 4, 5, and 6 to just show you that no duplicate data will come and no 1, 2, 3 data will come again. Okay. Let me just insert some data here. Okay. And it is inserted. Perfect. And now you will see fluctuation again. I'm not doing anything. My hands are there. See, and it will just rerunning everything after 10 seconds. And as you can see, it started pulling data. See the fluctuation, this one. See this fluctuation, it automatically picked the data. And now I will show you, see, I'm not doing anything. So now it will wait for more 10 seconds and it will just process the data again. But because of idempotent, you will see the decline in this graph because there is no data there, and it will just process the data exactly once. See, this is the power of Delta Lake structured streaming. And now if I just query this table, I should just see 6 records instead of like so many records because of the property called idempotent. 1, 2, 3, 4, 5, 6. Simple and sorted. This is your structured streaming. This is your structured streaming. I know this is very, very easy and very, very, very easy to understand and very easy to implement as well because of Delta Lake. Okay. So now we need to click on this interrupt. Why? Because we need to cancel our query. Otherwise, it will consume computation consistently. And we do not want that because clusters are really, really expensive. So do not need to do that. So we'll just simply turn off our query, stream. Now you can see it is grayed out. So now it is not running. Now if I just push the data there, let's say I want to just push the data again, let's say 7, 8, 9. If I just run this, data will be inserted in the source, but it will not be available in the sync because streaming query is stopped. Okay, see, no movement, no movement. Last updated 2 minutes ago. Query stopped. But if I just rerun it, it will be again running and pulling the data. Okay, but I'm not gonna do that. You can just play with it, but just remember, just turn off the query after running the data, after like pulling the data. Okay, and just to make sure, just to confirm, I don't have like 7, 8, 9 records. See, just 6 records. Perfect. So this was your structured streaming with Delta. I know it's really easy. I was also the guy who used to afraid of structured streaming, like how things are like happening behind the scenes, but thanks to Delta Lake. Okay. So this was all about Delta Lake streaming, structured streaming in Delta Lake. Now let's finally cover our last topic, last chapter of the day, which is Delta Live Tables. This one. Delta Live Tables. I know you are waiting for this one. So basically, Delta Live Tables is a vast topic in itself, and we will try to cover some fundamentals, and I will try to involve Delta Live Tables in my upcoming videos through projects, or maybe I will just try to embed this thing. But today, I will just set a very strong base, and I will just tell you that how you can create end-to-end DLT pipeline. Yes, we will be creating it. And for that, do you know, it will be using structured streaming tables. So that's why it is so important for you to understand this concept first, that is structured streaming. And now you know, now you're all set to understand Delta Live Tables. So let's see what is Delta Live Tables and what exactly we can do with Delta Live Tables. Let me just show you. So I think this is the best way to explain you the concept. So first of all, what is a Delta Live Table? What is a Delta Live Table? This is a hot topic in today's market. Delta Live Table, Delta Live Table. So basically, Delta Live Tables is like an ETL framework. Really? Yes, it is an ETL framework. So if I just go by definition, so you will say Delta Live Table is a declarative ETL framework Declarative ETL framework means we do not need to worry about the steps to implement the solution. We just need to define what we need to do. That means Delta Live tables will be taking care of all the overhead, all the implementation steps, all the maintenance, everything. And trust me, it will take care of everything. You just need to define what you actually need to do, like all the transformations, tables, views, everything. I know this is a very generic overview. You will understand a lot of things in just few minutes. Okay, so this is just by the definition. Now, if I just go to another documentation, so what exactly we can do with Delta Live tables and how it is different from workflows, because workflows is also a kind of ETL framework, right? So the thing is, workflow is not a declarative ETL framework. We need to manually build the pipelines. We need to manually orchestrate the activities. But Delta Live tables take care of each and everything. And workflows and Delta Live tables are different. They are different. Delta Live tables are useful when you just need to create a flow within a single notebook, right? And workflows is a broader term. You can obviously orchestrate Delta Live tables as well inside workflows. So when we say Delta Live tables, obviously it is related to Delta table. That makes sense. Okay, second thing, what exactly we can create under Delta Live table pipelines. So just relate DLT with pipelines. Okay. Okay. So this is a kind of pipeline or just a kind of framework, ETL framework. Within this, we get three kinds of objects. What are those three objects? First of all, as we have just seen, one is streaming table. We can create streaming table under DLT. Then what is the second thing? Second thing is mat views, or you can say materialized views. What is a materialized view? So if you do not know what is a materialized view, basically materialized view is a view that holds the data as well. Obviously, you know the view. View is just the thing that holds the query, but materialized views hold the data as well. Yes. So if you just go by definition, you can see materialized view is a view where results have been pre-computed. Obviously, as I just mentioned, that it will hold the data as well. Okay. And mat views are refresh according to the update schedule. Obviously makes sense because we need to update the schedule views. Then third thing is views, and we all know that what is a view. View is just the thing that holds a query, holds the logic, and every time we select anything from view, it will just compute everything again from the original data. Okay, so these are the three things. So I have designed something. So what we will be doing, we will create a pipeline in which we will be creating all the three objects. Yes. So first, I will show you. Don't worry. Don't worry. So this is all about the delta live table theory. Then we have another documentation which tells you how you can just use or create DLT pipeline using Python API or Python language. So we can also use SQL, but I love using Python and when I'm just working with DLT. So I will be using Python for that, and it's really really easy. Don't worry. And if you just go by documentation, do not scared, bro, because I'm here to just explain you everything. So I'm just showing you all these documentation so that you can just have a look on your own whenever you need to go in deep. Okay, so this is a kind of concept that you should learn in pieces, that you should learn slowly. Not slowly, I would say the right word is like divide that knowledge in pieces, master one piece, then go to the second one. If you will try to just learn all the pieces in Delta Lake in one go, you will face lots of problems. So first, just try to complete today's piece that we are discussing today, and we will just try to create a basic DLT pipeline, end-to-end pipeline, and you will have lots of understanding in the world of Delta Live tables. Okay, let's create that. So I was simply, this is grayed out, right? Yeah, last updated 12 minutes ago. I was just confirming because I have just used my premium workspace, so that's why. So simply go to workspace and let's create the last notebook of today's video. It will be 6th Delta Lake. Okay, perfect. I will attach my cluster. By the way, it doesn't make any sense. Why? Because we cannot run our DLT pipeline using normal all-purpose cluster. We have to create the job cluster. So it doesn't make any sense to connect it, but still I can just connect it to just check the syntax. I will just tell you, don't worry. So first of all, I will just create a heading and I will simply say delta live tables. Okay. So let me just have some area here. Okay. So the scenario is we have like so many tables here, right? In the rows on, we have so many tables. Okay. We will use this table stream source as our source. Okay. You can just use any table. So this is our source. Perfect. This is our source. So what we will do? So let me just create line. This is our source. So what we'll do? We will create a DLT pipeline. Okay. So first I will create a streaming table. Okay. This will be my streaming table and I will call it as bronze table. Okay. So that you can just relate it with Medallion architecture as well. So I will simply say, oops, bronze. Okay. And this will be a streaming table. Where I should write, I can just write it here. Okay. No worries. And this will be a stream table. Perfect. Then this data will go further and it will create a matte view, materialized view using this streaming table. Okay. So I will call it as silver. Okay. By the way, remember one thing, you can create streaming table using a streaming source. Either it can be another streaming table or it can be streaming view, but you cannot create streaming table on top of matte views. Okay. Because streaming table in DLT requires a streaming source. Simple definition. So this will be my matte view. Okay. Or let's say this will be my view because I will just apply some transformations, let's say. And obviously it's a view, so it will not hold any data, but I will just simply call it as silver. Okay. This is just a hypothetical situation. We are just building a very simple DLT flow so that you can just understand and you can just have a vibe of DLT. DLT is a very wide topic, so I will just try to cover these delta live tables topics in my upcoming videos. Do not need to worry. So, and for that you need a strong base. So that's why I'm building that base for you, that fundamental for you with practical. It's not just about covering the theory. So this will be my goal table or matte view. So I will simply say this will be my matte view. Perfect, perfect. So now when we create this pipeline, it automatically reads the data incrementally. That is another advantage of using delta live tables. So we do not need to apply any logic for incrementally reading the data. So it will be automatically reading incrementally data because this is a streaming table. Or it can be a streaming view if you want to read the data using a view. But if it is a matte view, then definitely it will just read all the data again and again. So that's why I just picked streaming table in the first step of the pipeline. So we will create these tables, and how we can create, do not need to worry. I'm here to tell you, do not need to worry. Okay. So this is the pipeline that we're going to create. So, and do you know the best thing? This pipeline, like the pipeline that was here, we do not need to actually manually build this. So it will be built automatically by Databricks. So without wasting any time, let's actually build that. So first of all, I need to just import DLT. Okay. So let me just run this and then I can simply say %md bronze streaming table. Okay, perfect. So now I will simply write the code. What is the code? So first of all, I need to create dlt.table, which will be my table name. So now I have now two options. What will be the name of my table? I can simply pick name equals bronze table. Okay, this will be my table name. So now I need to create a function to actually feed the data inside this table. So I will simply say def bronze table. So now a quick question before performing anything else. Do we need to keep the function name same? No. You can pick any function name, let's say bronze table. It will not bother this function name till the time you have provided name here. If you do not provide the name here, then it will pick this function name as the table name. Okay, so let me just put the name as it is, and then I can simply say df equals spark dot read, and we are just creating a streaming table, so stream dot table. And what is the table name in our scenario? Delta catalog dot raw dot stream source. Perfect, perfect. Okay, then do we need to perform any transformations? Not really, because in bronze layer we do not do anything. Then simply I will say return df. So what it will do, it will create this Python function, it will read this data frame, and then it will just feed this data into this table. This is my bronze table. Okay, this will be my bronze table. Let me just run this. Don't worry, nothing will happen because it uses job cluster, so you can just see the syntax is fine, that's it. You cannot see the pipeline, don't worry. Then I will create something called as silver view. Okay, let me say silver view. Then in order to create a view, I will simply say dlt dot view. Okay, and if I do not pick any view name, as I just mentioned, it will just pick the view name using function name. So I'll simply create a function called silver view, and I will simply say df equals spark dot read. Now instead of using read stream, we need to use read dot table, because we are not creating a streaming view, we are just creating a normal view. Okay, read dot table. And what will be the table name? Now is the tricky thing. As you know that we need to create a flow, so this view will be reading data from this table. Where is this table residing right now? Nowhere, nowhere. So we need to use a keyword called live. Then I need to pick the table name, which is bronze table. Simple, perfect. Now it will be reading the data of the live schema, which is the current one, and then it will just return that. Return df. Perfect. Now I can just simply run it. Perfect. Now I will be creating gold matte view. Okay, perfect. Then I will say I will create DLT matte view. For that, we just need to pick DLT.table. Yes, we use the same thing. Then I will not give it any name. So I will simply say DEF, and I will say gold matte view. Perfect. And it will simply pick that matte view name as it is, gold matte view. Then I will say df equals spark.read.table. And what will be my table? It's a view, and we will be using live. Simple. I know it is not easy to understand. Just rewatch this part again and again. You will get to know, and just watch this part completely first, then rewatch it, because you will see the flow that is building right now. Okay, so let me just run this as well. So this whole pipeline is created. Yes, it is created. So now what I'll be doing, I will simply terminate my current cluster. Okay, and then once it is terminated, yeah, so now it is terminated. Now we will create the pipeline. How? Simply click on these three bars, click on delta live tables. As you can see, currently we do not have anything. Click on create pipeline. Now within this pipeline name, we need to name it, so we can simply say DLT tutorial. Okay, and product edition, you can just pick advanced. Pipeline mode, we will be picking triggered. Source code, now we need to pick the notebook where we have created DLT code. Okay, pick the same, we know it is sixth one, pick it. Okay, now are we using Hive Metastore or Unity Catalog? We will be picking Unity Catalog. I know this is in preview right now, and that's why if you closely observed, I didn't create external delta live tables, I created manage delta live tables. So for now, if you just go here, you can define something called as, let me just show you. Yeah, so this is the code. So as you can say, as you can see, we have used name here, but we have something called as path as well, where we can define the path for external tables. But I tried using path multiple times in the past. I didn't use it now. I don't know if it is added now or not. I used it like in the past, but it was throwing me errors, so that it was saying that it cannot create external tables because this feature is not available yet. So it is only creating managed tables with Unity Catalog. That's why you are seeing this Unity Catalog is in preview. So if you're using Unity Catalog, you have to first create managed tables, and it is fine. Don't need to worry. Then we need to pick the catalog. So if you want to use the current catalog, it is fine. And I want to use the current catalog. Now, what is the target schema? As you know that we will be creating three objects. One is streaming table, second is view, third is mat view. So in which schema you want to pick? Like if you want to push that data. One thing is picking the normal one. Okay. If not, you can create a new one. So I will show you how you can just create a new one. Simply type, I will simply say DLT schema. So it will just create a new schema. Okay. Perfect. Compute, we need to pick none, and auto scaling, we do not need to do that. We just need to pick fixed size, and we will just pick one worker node, and then just scroll down, and then you just need to pick worker type. So just pick DS3v2, DS3v2. Perfect. Then click on create. So it will automatically create the flow. And do you know it has automatically created the flow? So if I just click on this drop down, like if I just hide it, we have two modes, development and production. So if you are just debugging the pipeline, if you know like some errors can occur, and if you want to just make some changes, you should always run your code or pipeline development, so that it do not need to just recreate the cluster, because it takes a lot of time to create the resources, to create the worker nodes. So you will see your pipeline will take a lot of time initially when you will be running it. So I will simply click on start, and I will show you it will just create the flow. But before that, it just needs to create the resources, so it will take some time. So let me just click on start. So now as you can see it is showing waiting for resources. So it will just create the resources, and it will take some time to create the resources. And once it is done, then you will see the whole flow here, like having three activities. One is for streaming table, second is for view, third is for mat view. Okay. So just hold on for like I think 5 to 6 minutes. Once it is done, you will see it. So let me just fast forward it. So till the time it is creating the resources, I just need to share one very important knowledge, and it's very, very important. So the thing is, as you know that we have first terminated our all purpose cluster. So then we created this one. If you do not terminate your current one, like the current all purpose cluster, and then you create this DLT pipeline, there are chances that this will fail, and this will show the error of like quota is reached, maximum limit of quota is reached, because per account you just get 10 cores, and in our all purpose cluster we were using 4 cores. And when we picked two more cluster, like two more nodes here, so we just picked 8 cores, which adds up and create 12 cores, whereas your quota limit is just like 10 cores. So whenever you want to run your DLT pipeline, you have to terminate your all purpose cluster. Yes, it is a chaos. You can just raise the request to increase the quota limit. Otherwise, you have to just do it like this. Whenever you need to just run your normal code, normal notebook, you just need to first terminate this one, DLT pipeline, then run that. And once it is done, then you need to terminate that all purpose cluster, and then you need to just complete this. I know it is a kiosk. You can just, if you are using pay as you go, your pay as you go account, you can just raise a request to just increase the limit. Otherwise, you just need to do this back and forth thing, like just delete, terminate the cluster, and then restarting it and all. So I know it is a kiosk. So if you are using free account, I don't think so you can do it. But if you are using pay as you go account, you can definitely increase your quota limit. I also want to increase it, and I will just see like how long it will take. So I was also using DLT pipelines in my hobby projects like this. But obviously, if you're just dealing these things in the organization or in the real world, they have like lots of quota limits, so you do not need to worry. But if you're just building some kind of hobby project, then it is a good tip, because I was just troubleshooting it, and it took a lot of time for me to actually find the root cause. So when I just found it, I thought to just share it with you as well. So always remember, just terminate your all-purpose cluster whenever you're running DLT pipeline. Okay, so now let me just share one more thing till the time it is creating this. Why it is shaking, man? View logs, query history. Okay, so why DLT pipeline is very much in demand, and why do we need to like actually be inclined towards delta live tables. So the thing is, if you just go here to the documentation page till the time it is running, I can just show you that it will just take, I think, 1 to 2 minutes more, because it takes, I think, 6 to 7 minutes to create the resources, and then we can just troubleshoot if we see any errors. Otherwise it will be done, do not need to worry. So if you just go here in the delta live tables, so why it is so good? So the thing is, it's not just about creating the pipeline. Creating the simple pipeline is so easy, right? Like if you will ask me, hey bro, will you just pick DLT over workflows if this is the only functionality of DLT? Obviously my answer will be no, a big no. Okay, but let me just share you some interesting functionalities of delta live tables, and after knowing this, you're gonna love this, you're gonna love this tool, trust me. So I can also check it for one more time. So it is still running. So I can just show you what do I mean. So let's use this thing, and I can simply say DLT pipelines. Okay. So the best thing that I love about DLT pipelines. So if you know a little bit about data warehousing, slowly changing dimensions, you would know that taking care of slowly changing dimensions, especially type 2, it is very like not hard, but like lot of overhead and lot of maintenance is required to actually managing those tables, like SCD type 2 especially, where we need to keep the history as well. So first of all, let's say this is our source. Okay, and this is like 1 2 3 column, like values, and let's say this is the name, and this value was AA, this value was BB, this value was CC. Okay, and this was created, and we created our dimension on top of it. Okay, then on the next day, or let's say after a month, we see a change, and the value for third ID is now XX instead of CC. So at that time, we need to just take care of all the changes. But do you know, with DLT pipelines, we do not need to take care of slowly changing dimensions, because we have a function called, let me just show you, apply changes API. When we say apply changes, it takes care of all the maintenance work of slowly changing dimensions. Trust me, it is so powerful. So you just need to define that what kind of slowly changing dimension you need to create. Let's say you want to create SCD type 1. You just need to say, just create a slowly changing dimension type 1. That's it. I'm not kidding, bro. Just type this. That's it. It will create slowly changing dimension type 1. Then you will say, create slowly changing dimension type 2. It will say okay. Yes, it will create slowly changing dimension 2 as well for you, and you do not need to do anything. You do not need to take care of initial load, you do not need to take care of incremental load, you do not need to take care of create and update date, you do not need to take care of pulling the maximum surrogate key, you do not need to take care of start date and end date in case of slowly changing dimension. You do not need to take care of anything. Delta live tables will be taking care of everything, and that is one of those features of delta live tables that I love a lot. I love a lot. Like other things are fine, but the best thing is slowly changing dimensions. Yes, so try to explore these areas on your own, and let me check the progress of our current pipeline. Wow, man, wow. I don't know why it is shaking. Let me just click on this cross button. So this is the pipeline that DLT has created for us. So now, as you can see, this is a kind of streaming table, and this is a symbol for streaming table. Okay, and as you can see, it has read 9 records because we just had 9 records, right? Then it created a view. It created a view. Yes. Then it created a materialized view, and this is the symbol for materialized view, this thunder button, and it has read 9 records. Did I create this flow? No. DLT created on its own. Now, as you can see, I am running my pipeline in development mode. So what is the best benefit of it? Let me just show you. If I just go to my recent tab and if I just open my notebook, the sixth one in which I have written the code, let's say I am having some errors and I want to debug it. So I will simply go here, and instead of connecting to my all purpose cluster, now I have the opportunity to connect to my job cluster, which is this pipeline. I can simply say connect. So it will just give me the view here instead of there. See, this is the thing. And delta live tables, and then you can simply debug your notebook here. You can just simply see the output. You can also click on validate button if you have like more records. So as I have just mentioned that it will only incrementally read the data. So let me just again click on start button, and this time this will not take much time because resources are already ready, and in development mode the cluster will not be killed. So it will simply say initializing, and waiting off for resources step is already done. So now you will see my streaming table will bring 0 records because of the property called idempotent exactly once. So it will not read 9 records, 8 records, no. It will simply read 0 records. It will not bring any records. So as you can see, it brought 0 records. Okay. So now when it brought 0 records, okay, then my view will read all the records from the table, not from this live table, the whole table. That is the reason that you are seeing here 9 records inserted. So why it inserted 9 records when I have here 0 records? So the thing is, now this view is reading all the records existed in this particular table, not just based on the flow, but the real table. And we already know that this table had 9 records previously. Obviously, in the physical table format, it also has 9 records. So this view will read all the records. To mitigate this problem, to mitigate this issue, we have something called as append flow. Append flow. When we say append flow, we just put the data, or you can say incremental data, because in case of append flow, we create a streaming table here instead of just creating a view, because view will read all the records every time, every time. Or you can just create a streaming view, that is a different story, but for now it will read all the records. Okay, so now if you want to create a streaming view, you can just play with this pipeline, and append flow will definitely solve the problem, because in append flow we just create a streaming table instead of a view. So I just said that delta live tables is a wide topic, and there's like so much to discuss, so much to play with. So this is all about exploring it with the time. So I will just leave this topic with you, not the whole topic. Now you have a ground base ready for you. Now you can just play with it, because now you know like how to create all the objects, and now you can just connect with your source and just put the data in sync and just play with it. So this was all about today's video, and I hope you love this video. You love the learning that you gained, and like all the knowledge that you gained so far. And trust me, this knowledge will definitely help you to crack your dream companies. Trust me, because this is the knowledge that is very much in demand, very much in demand. So now what is the next step, next action for you after completing this Delta Lake. So as you promised that you will be watching Databricks Unity Catalog video, and if you watch Pyspark video as well with that, that will be the best combination: Databricks, Pyspark, and Delta Lake, and you are all set. Just complete all those videos as well if you haven't watched those videos, and if you have already watched those videos, then I will strongly recommend you to complete the recent project that I have created, and it is 7 hours long project, and that project is like industry ready project, that is a job ready project, and that is using data factory, Databricks, star schema, you can say dimensional data modeling, slowly changing dimensions, everything. So these are your next steps, and I will see you there. Love you a lot. Bye bye.